books, they will be separate cookies, separate memory, separate sessions. Behind you, yeah. Really good question. When does the session end? Totally configurable. Typically, it ends when you close the tab or when you quit the browser. Or you can also configure cookies to themselves be persistent for a day, for a week, for a longer. So for instance, when you log into say Gmail, they plant a cookie on your computer probably for a week, a month, a year, something like that, because it would be annoying and probably drive you to like Outlook or something else if you kept having to log into your account, whereas your bank account might actually wait for you to just close the tab, and then for your own financial safety, they just automatically delete the session far sooner, but totally configurable. By default, as I'm using it, it will typically be thrown away when the browser itself quits. And here, too, is another reason to develop websites using incognito mode, because if you want to just throw away all of your cookies, you close the incognito window mode, open a new one, and now you're starting from scratch. You don't have to manually delete all your cookies, which could log you out of websites you actually care about. Yeah? A good question. When using sessions, if someone maliciously changes the value of subforms, could it affect other people? Theoretically, no, because the worst you can do is like add books to your own shopping cart that you don't want there. So at that point, even though it's on the server, it doesn't affect you or Carter or anyone else, unless there is something more globally happening, like registering or deregistering for a sport or removing books from the Amazon database. That would be problematic. But in this case, we're removing things only from my own session that the website is giving me. All right, the last topic for today is this thing here, which is sort of everywhere nowadays, these things called APIs, or Application Programming Interfaces. And this is a very generic term, in fact, because any function you've used in C, in Scratch, in Python, in SQL are all APIs. Like there is a standard way of interfacing with those functions. They all have names. They sometimes have return values. They sometimes have arguments. And an API is just how you use a function. Or, more generally, an API just specifies how you interact with some service. And so nowadays, there's a lot of web-based services that you can use to get back data, like the weather, or the current time, or the database of Amazon books, for instance. All might have APIs, often web-based, that allow you, using URLs or some other technology, to just get data from someone else, as though it's a function you're calling remotely. But HTTP is very often the mechanism that's used to actually get data from servers. And the way the data can come back can be as follows. Let me end with one final example using some of our familiar shows from weeks past. Let me go ahead and close the old Flask version, go back into source 9, and go into how about an example called shows. And the first version of this 0, I'm just going to go ahead and run with Flask run. I'll hover over my URL and open it here. And you'll see now that I have a very simple form, as we keep doing today. I'm going to type in like OFFICE office into this search box and click search. And you'll see now that I ended up at a URL ending in /search !Q equals office. So this is like my own baby version of google.com, but I implemented it myself. And for any title of a TV show from a couple of weeks past that matches OFFICE, I spit it out into an unordered list. How is this working? You can maybe imagine, even if you might not be able to program this off the top of your head certainly so soon. Let me go into source 9. Let me go into show 0. Let me open up app.py. And in this file, you'll see that I'm grabbing a file called shows.db, which is like a simpler version of the one from a couple of weeks past. Here is why I see the web form. My first route, my index, is super simple. It just spits out that form. And my search route, like you can think of this as google.com, is only like 4 lines of code. So if the user sends data to /search, this function called search is called. I declare a variable called shows. I execute a SQL command that is select star from shows where title like ? And the syntax here is a little crazy, but I want to prefix to the user's input %, and suffix it with a % as well, putting in the between those two values the actual input y. In SQL, what does it mean if you have a % to the left and to the right? Nothing to do with Jinja today. Yeah, it's a wild card. So it means match 0 or more characters on the left or match 0 or more characters on the right. You have to do the concatenation as the second argument to this function. You can't do something clever like put it here around the question mark. Like the question mark is the placeholder that you plug these values into. But this just means, hey, SQL, show me all of the titles that have OFFICE somewhere in them. That gives me back a list of dictionaries. I pass that in as a placeholder for a variable called shows. And if we look at search.html, let's look at that. In my templates directory, there's something called search.html. Super simple. I mean, this is like the essence of google.com search results. I'm using an unordered list to keep things simple, but I iterate over every show in the shows list that came back, and I output an li with each of those shows titles. And that's it. Now, Google has like blue links and like little previews and other text, the first sentence or so from each page, but like that's the idea. Like this is really similar in spirit to what google.com/search does for you. Now, how is this working? There's no API involved here yet. This is just very basic HTTP. I submit the form, I go to another route, and I get back the results. But check out this version. Let me close these tabs here and open my first terminal window. Let me go into shows 1 from today's source9 directory and do Flask run this time. Let me go ahead and hover over that URL and open it here. And gone now is the submit button. Now I'm going to make a user interface that uses a technique called AJAX for asynchronous JavaScript and XML, which is somewhat of a dated term because we're not using something called XML anymore. But AJAX is a technique whereby you don't have to submit forms anymore to get more data from the server. You can use JavaScript per last week, listen for an event like the key press coming down or up, and as soon as you hear such an event, you can secretly, in JavaScript code, send a request to the server to get back more data and then plug it into the DOM, the tree in the computer's memory. And this just makes for more seamless experiences like autocomplete on any website. So now let me try typing O. OK, we got autocomplete super fast. F-I-C-E. And you'll see every time I add more keys to my input, I'm doing another search, another search, another search, and the data is changing. Now, how is this working? Well, let me go back to VS Code here, and in my other terminal window, let me open up app.py. And in app.py, you'll see that there's still a search route down below that returns a search template. But watch this. Let me go into templates/search.html and notice here that we're indeed getting back an unordered list of shows again and again and again. And this HTML that's coming back, let me go here. Let me open my terminal. Oh, sorry, this is the wrong version. Sorry, I was in the wrong folder. Let's fix this. In shows 1, code of app.py, it's almost the same thing. In search here, OK, well, I changed this slightly. Let me show you this version of search. If I open up app.py, here's my search route. I'm getting a variable called q, giving it the value of whatever request.args has from the user, like q equals office. And then I'm checking. If the user actually types something in, execute this SQL query. Select star from shows where title is like that, using the same. And this time, just to keep things efficient, I limited the total results to 50 instead of an infinite number. Otherwise, if the user typed nothing, just to be super safe here, I'm setting shows equal to an empty list. So if you don't type anything, there's nothing to show. And no matter what, I render this template called search.html. Well, let's look at that. If I open up templates/search.html, this time there's no layout. There's no inheritance of that layout.html. I am literally generating just a whole bunch of li fragments. Why? Well, let's see what's happening in the browser. And this is the beginning of an API. If I wanted to make this API available, this application programming interface, I could tell the world that if you want to search for TV shows in my database, go to URL that's something something / search q equals office or cat or dog or anything else. And what I will return to you is this. Enter. I will just give you a whole bunch of li tags, which almost looks the same, but let me view the page source. Only am I going to hand you back a fragment of HTML. I'm not giving you an HTML tag, a body tag, a title tag, a head tag. I'm not giving you a web page. I'm giving you a fragment of HTML that you can now do whatever you want, including insert this into your own unordered list. So notice what happens in this actual app. If I go back to VS Code here, let me open up my index template here, and you'll see some JavaScript magic. So in JavaScript here, in my form that only had the text box and no button, what am I doing? In a script tag here, I am creating a variable called input. And I'm using this function called querySelector that just gets me a reference to the input text box on the form. So I can see what the human typed. This is a little different today, but I'm using input.atEventListener, which is a way in JavaScript to tell it, just like in Scratch, listen for something to happen, like the green flag being clicked. But in this case, listen for an event that involves input. That is like typing on the keyboard, whether it's by a copy-paste, manual input, or anything else. Then, whenever that happens, call this function. And async stands for asynchronous. This is a term of art, which means that this function might take like a split second, maybe even a second or two to execute. So it's going to do it behind the scenes, like in the background, so to speak. And what is it going to do? Well, it's going to call a JavaScript function that all browsers now support called fetch, which is a function that uses HTTP to go fetch more data from the server. It's going to fetch data from a route called /search, !q equals, and whatever the value is that the user typed in. So I'm just sort of manually creating my own mini URL and telling JavaScript, go fetch me that HTML. When it comes back via this line of text here called response.text, and let me wave my hand at await. Await just means this might not come back immediately. Let's await the response. And when it does come in, then let's execute this code. I'm going to do this. I'm going to search the document, the whole web page, for this UL tag, which is somewhere in this page that we'll see in a moment. Change its inner HTML to be that fragment of li, li, li of all of those matching shows. And where does this all go? Well, if we scroll up here, you'll notice that there's my usual HTML up at the top, head tag, body tag, and all of that. There's the text box that we've talked about already. There's no button for submitting because it all happens automatically. But there is, by default, this empty UL that has nothing by default until we start using that API. And the final flourish here is this. This is kind of an ugly, sloppy way to get data from a server to just get back like a fragment of HTML. Like, what if I'm not using HTML? I want to store these TV shows in a PDF or in some other wet tag, in a table or something like that. It doesn't really make sense for the server to be presuming that I want li tags surrounding each of my data. Better would be to get a more generic format back. And that format is almost always nowadays called this, our final acronym, JSON, JavaScript Object Notation. And let me do this. Let me close these two tabs here and open my terminal window and cancel the previous version of Flask that was running. Let me close this version and look at our final version called shows2 and do Flask run. I'm going to hover over that URL and open it in a browser. And I'm going to manually visit, after zooming in, let's do again /search !q equals office, enter. And this is what JSON looks like. Now, at a glance, this does not seem like an improvement. Like, this looks crazy that it's just this big blob of text. But it's just enough text for the computer to be able to process it reliably. Notice that there's a square bracket here. And if I actually scroll to the bottom, there'd be a closed square bracket, like way down there. Inside of that square bracket is a curly brace, then ID, colon, and then a number, then a title, quote unquote, colon, and then the title, and then the closed curly brace. So what you're seeing in JavaScript object notation is a very standard, super popular format that's just text, that still uses square brackets for lists, aka arrays, that still uses curly braces for dictionaries, key value pairs. So what you see here is a massive list, up to 50, I think, shows that came back from this API, each of which has a dictionary, if you will, an object of key value pairs. What keys and values? An ID key and a title key, each of which has a value respectively. And this is the same data from IMDb, some of which you might be recalling visually. This is just a very raw, computer-friendly way of returning a whole bunch of data that we humans don't need to see. But I can use this data by going back into VS Code. Let me open another terminal window and go into source9/shows2. And in here, let me go ahead and open up, how about templates index.html, which previously just used that inner HTML trick. And this is not going to impress, you're not going to be pleased with this syntax. But let me just at least explain what we're doing. It turns out that JSON is just the better way in general, the more generic, multi-purpose, user-agnostic, language-agnostic way of returning data from a server, because it's just text. So it doesn't matter if you're using Python or C or C++ or JavaScript or Ruby or PHP or something else. Like, all of those languages can process JSON information. And indeed, here is some JavaScript that does just that. Same code as before initially. I declare a variable called input that gives me access to the user's text box. I listen for input, like keystrokes going up and down. And when they happen, I call this anonymous function. I fetch data from the server using the exact same code as before, search, question mark, q equals office or anything else. And then this is just now new code that I use to convert that JSON data into my own HTML format, be it an unordered list, an ordered list, a table, or anything else. What am I doing? I've got a variable called HTML initialized to nothing. So I've got no HTML initially. I then iterate over every ID in those shows. So every one of IMDb's unique identifier, I iterate over them one at a time. And then I go into the show, add its ID location, and I grab its title. And this is, forget this for just a moment. I then take this HTML variable, concatenate or join onto it my own li tag plus the title plus the close li tag. And I skipped this because it got scary pretty fast. But it turns out that if some TV shows have actually angled brackets in them, that could break my HTML entirely. So it turns out, you might recall super briefly last week, we had the copyright symbol using an HTML entity using the ampersand and the hash symbol and 169 semicolon. It turns out there are other such cryptic sequences of characters that represent otherwise dangerous or untypable characters, like this, which could confuse the computer into thinking it's at the beginning of a tag, and an ampersand, which could similarly trick the computer into thinking that it's a entity, which it isn't. But long story short, there are libraries, thankfully, that handle much of this for you. For our purposes, the takeaway is that now that you understand a bit of HTTP, now that you understand a bit of HTML, CSS, and JavaScript, all of which they have their roles, you can use them ultimately to start assembling your own web applications, as you will for problem set 9, stitching together all of those languages and building full-fledged web applications, mobile applications, or anything more. And for that, I think we are all set. And if the first one up here can have these cookies as well. We'll see you next time for our very last CS50 lecture.
Good afternoon. My name is Sarah.
And my name is Grant.
And we are
the Harvard Crocodillos and the Radcliffe Pitches. Now, Sarah and I understand that today is the final lecture of CS50.
It's been a tough semester. We made it through PSETs 4, 5, and even finance.
Now, I know this is an unpopular opinion, but I particularly enjoyed finance. I spent a lot of time with my Flask.
The P set?
There was a P set?
Well, at least things are looking up. Today is our last lecture, and look how far we've come. If I were an emoji right now, I'd be the face with tears of joy.
Sorry about that. We're just trying to work some CS50 references into the intro. I mean, boy, I sure hope this Tide Man doesn't run off my Mario filter.
You could say that. For loop x equals open bracket 1, 2 close bracket.
Boy, I sure wish we had Check 50 to see if these jokes were funny when we wrote them.
Good afternoon, everyone. We are the Harvard Crocodillos, and it is such an honor to be here with the Radcliffe Pitches performing for CS50's final lecture. Congratulations to everyone, and we hope you'll enjoy this, our tribute to CS50. One, two, 3, 4. Da da you da you da 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 you da you da 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 da.
C is for the language I once knew. O is for all notation I must do. D is for dynamic, flask run and finance it. E is even more than David Malin can adore. So code is all that I can give to you. Code, debugging it since P set 2. Soon deadlines I'll make it. Hit compile and please don't break it. Code was made by me for you. C is for the language I once knew. O is for notation I must do. D is for dynamic, flask run and finance it. E is even more than David Malin can adore. So code is all that I can give to you. Code, debugging it since P set 2. Soon deadlines I'll make it. Hit compile and please don't break it. Code was made by me for you. C is for the language
01000100.
O is for O notation
010010.
D is for dynamic, flask run and finance it. E is even more than David Malin can adore. So code is all that I can give to you. Code debugging it since P set 2. Soon deadlines I'll make it. Hit compile and please don't break it. Code was made by me for. Code was made by me for. Code was made by me for you.
All right. All right, this is CS50, and CS50, this was the Harvard Crocodillos and the Radcliffe Pitches. If one more time, we could thank them for joining us today. So this is already week 10, our last, and indeed among the goals for today are to hopefully give you all the more of appreciation of truly just how far you've come. Recall that in week 0 we began with this visual here, whereby it was described, this class, as a bit of a fire hose, whereby drinking from that fire hose, or really a fire hose from a water fountain, is not unlike getting an education down the road too. And so this is to say that if you're feeling like you didn't quite get it all down, like that's actually okay, and that's to be expected. And even if you felt that with each passing week 0, 1, 2, all the way up now till 10, it never really ever got easier, perhaps, just consider that what was once hard, like Mario and like getting Hello World to compile, is indeed the right measure of the delta between week 0 and now in week 10. In fact, you might recall that again in week 0, 2/3 of your classmates had never taken a CS course before. Now, of course, you all have. And indeed, if you think back to this final sentiment from week 0, that indeed what ultimately matters in this course is not where you end up relative to your classmates, but where you end up relative to where you yourself began. So I would take some pride, take some satisfaction, take some relief, even though a little bit more work does remain, at really just how far you've come since that week 0. And recall that in week 0, we literally started with just 0s and 1s. And by now, many of you might have gleaned that these 64 0s and 1s have been spelling something week by week. In fact, today is our very last message here in binary, encoded on stage. But then quickly we introduced Scratch, and we started to assemble some building blocks of programming, loops, conditions, functions, and the like, but without all the distractions of semicolons and curly braces and all of that, which admittedly we introduced the next week when we introduced you to C. But even now that we've transitioned to Python, hopefully even those kinds of curiosities or confusions are hopefully starting to just get more familiar. And so you finally start to see the missing semicolon as opposed to spending time on that kind of struggle. Recall too that in week 2, we started talking already about memory and like how you can manage things in arrays that later became, of course, in Python lists. The week after, we talked not only about debugging bugs in code, but how to debug those same programs. Thereafter, we started talking about algorithms, and we took a step back from code and looked at the bubble sorts and the selection sorts and the merge sorts and all of the searches as well that go hand in hand with that. And indeed, this ultimately is what a lot of problem solving moving forward is going to be about, just solving problems with some form of algorithm. And you have so many different languages in your toolkit now with which to approach problems like those. We talked thereafter about pointers, which are not likely to come back in any modern languages that you now use, but hopefully you have an all the better of a sense underneath the hood of like what's going on inside of the computer, so that when you're designing something, you're using something, something crashes, you at least have a mental model for what's going on, and it's no longer that week 0 black box as it once was. I mean, you built things like this. Think back to week 5 when you built your own hash table, and those things are everywhere. Key value pairs, whether it's in Python or in C, or if it's now in CSS and JavaScript and even HTML, like that principle of key value pairs is really everywhere. And so, of course, now code doesn't necessarily have to look like this. It now wonderfully looks a little something more like this. But eventually, you're probably not. I'm not going to use Python anymore. Something new and better is going to come along. But odds are, like a lot of the building blocks from these past 11 weeks are still going to be useful for wrapping your mind around those new worlds. And indeed, SQL, we introduced you a little bit too. And even if you don't feel yourself yet an expert, hopefully you have a sense of like what you can do with it and what problems you can solve. It's, of course, a better alternative to something simple like a spreadsheet. And now, of course, like web stuff is everywhere, whether it's on your laptop or desktop, or even a lot of the mobile apps that you use on your phone, even though they're native applications, like you install them from Google Play or the Apple App Store, like they're implemented increasingly with HTML, CSS, and JavaScript, but they're put in a little rectangular window so you don't even notice that that's actually really just an embedded browser. And then, of course, you can build things as you might for your final project that too might very well be web-based if you go that route. I mean, I'm still clinging to like the very first like web app I ever made years ago. But honestly, I do that in part because I was just so darn proud that like I taught myself how to do something and it actually worked and was used by other people. So whether it's just used by you or your classmates or your roommates or your family or your company down the line, there's a great sense of satisfaction that comes despite all of the pain that might be along the way when you just can't see or fix that bug. Now, of course, we'll transition, as you'll see in the coming days, to empowering you to code client-side as well. Up until now, you've been using our own VS Code installation in the cloud, which is nice because you got up and running super fast in week 1, focusing only on code challenges, not on technical difficulties. But among the goals now, if you so choose and want to program after this class, even if you never take another CS course before, you can use these same real-world, de facto standard tools on your own Mac or PC. And so pictured here is a screenshot of like VS Code on the Mac. And even though, yes, you're going to have to like jump through a couple of more hoops to just get Python or some other language working on your own Mac or PC, like that's what programming is ultimately going to be about. And we deliberately transition you to this at term's end so that now you have 11 weeks of more comfort under your belt with which to solve sort of silly technical support headaches that might have been deal breakers so many weeks ago. So there's still more to be done in the coming weeks, and indeed a support structure therefore. The CS50 Hackathon, of course, will be this 7 p.m. till 7 a.m. opportunity to dive into your final project, well, really continue diving into your final project, ideally at that point, alongside classmates, perhaps your project partners if you're working collaboratively. And awaiting you will be such memories and excitement, hopefully, as these, even as you then turn your attention back to your final project. There, of course, will be several meals during the day, culminating with 5 a.m. Shuttles to IHOP, the local pancake place, if you are so awake at that point. Or even if you get there, this is not an uncommon sight, as you might recall from week 0. And then lastly is the CS50 Fair, which is finally back after a couple of years now of it not being on campus. And this will be an opportunity for everyone to present their final projects to passersby, classmates, faculty, and staff, and really just delight in what it is you created on your Mac, your PC, your phone, in the cloud, or anywhere else. And indeed, it's just going to be an opportunity to bring your laptop to a shared space or your phone and introduce your project to passersby, such as might appear, and ultimately celebrate what you all accomplished. And indeed, will you be handed at the CS50 Fair your very own I Took CS50 t-shirt, which I dare say I'm still wearing all of these years later. And so you too will have that ahead of you as well. So for what's on the agenda today, we thought we would not only look back but look forward. But first, we wanted to thank so many of the team members that have been helping both on stage and off, who've made this course and these sections and so much more about CS50 possible. Of course, the building that we are now in, there's a whole team downstairs in Memorial Hall who helps us get set up and organized each day. Our thanks to them. There's the Education Support Services team who makes everything look and sound so well down here, especially when we have all of the more microphones as well. Our friends, the Harvard Crocodillos and the Radcliffe Pitches most recently. And then, of course, CS50's own team. CS50's own favorite restaurant, Chang Shou, down the road. Indeed, if you find yourself in Cambridge for the next 1, 2, 3, 4 years, or visiting from out of town, do pay a visit to our friends just down the road. And in fact, we'll have our very last CS50 lunch this Friday if you're able locally to partake. And then there's CS50's own team, both on stage and off. And my thanks truly, because not only do they make everything run so smoothly, they capture it for students here who might not be physically present here, for our friends down in New Haven at Yale, and certainly for anyone online who might be tuning in as well. And then lastly, wanted to thank, of course, the huge team of your classmates, your peers that make CS50 possible in sections and office hours, tutorials, and more. Allow me to share with you the outtakes so that even we, the teaching staff, sometimes struggle with computer science. Here are some of the clips that we captured when just passing packets via TCP/IP a while back. You saw the nicely polished version, but here are, if I may, if we could dim the lights, are some of the outtakes. Okay, good. Buffering, okay. Josh, nice. Helen. No! It's Monica. No, oh, wait. That was amazing, Josh. Sophie? Amazing. That was perfect. Moni?
I think I.
Over to you all.
Oh, nice.
Guy? That was amazing. Thank you all.
So good.
Indeed, in that moment, if we could, just one round of applause for everyone who's helped out this semester. So back in week 0, we introduced you, of course, to this idea of computational thinking, which is to think a little more methodically, a little more algorithmically. And by way of these various languages, hopefully that is something you notice, maybe not in the moment, but in the months and the years to come, that you do find that your thoughts are indeed a little more cleaned up. And you're just able to express yourself a little more precisely and even spot illogic in someone else's document or statements as well. But at the end of the day, really, a course like this is also about critical thinking. And indeed, rewind again to week 0 when we framed the entirety of computer science as really just this, like problem solving. And any problem in the world, be it CS or otherwise, has some input, and we decided how to represent those inputs. It needs some output, the solution there too, and then all of what you focused on doing and learning and applying these past several weeks is in that proverbial black box, which hopefully is not such an abstraction anymore, but is indeed something that you know how to harness and know what could be going on underneath the hood, even if it's in some technology or some language that maybe we ourselves didn't cover, because a lot of those first principles remain the same. Now, along the way, we talked about the quality of solutions to those problems. We happen to focus on correctness, just does it work, design, which is a bit more qualitative and subjective, and then style, the aesthetics of it all. And these two are characteristic, maybe not with these same words, of just how you might write or evaluate other creations in life, be it physical or written or the like. So think about, too, as you solve problems, just how you can sort of frame for yourself, like, am I doing a good job or not, by quantizing it along these or perhaps other axes as well. And we thought we'd highlight just 2 topics from that week 0 that have really been manifest for the past several weeks, namely abstraction, like taking complicated things and ideas and trying to simplify them so that we can sort of operate at this level and like solve problems we care about without getting into the weeds of implementation details, so to speak. But there's this tension because you know now from all of these different languages that code is fairly unforgiving. I mean, even omitting a stupid semicolon sometimes breaks everything. And so precision is sort of at odds sometimes with this idea of leveraging abstraction. And so we thought we would try to tease this apart, especially all these weeks later here, but with a bit of a live demonstration. So on the way in, you probably all received a sheet of paper. If not, but someone near you did, just tear theirs in half and borrow half a sheet if you can, or any piece of loose leaf paper or the like will suffice, so long as you have a pen or a pencil. And for this, allow me to propose that we invite up maybe 2 final CS50 volunteers this semester. And like a lot of hands are going up in this. OK, a lot of hands. How about, I saw the first hand there. Yes, who's pointing at herself now? Come on down. We just need the one hand for now, but come, oh, wait, you'll be our number 2. Well, OK, we have way too many volunteers now. No, please, come down. Yes, in the black shirt. And if you guys, we'll do pair programming in just a bit. If you want to hang out in the wings here, we'll have our second demonstration as well. So, OK, now maybe a round of applause for our 3 volunteers. Oh, come on up first. Oh, no, second and third. OK, you come first. We'll do order of, no, this is a Q. OK, Q, here. OK, what's your name?
I'm Danny.
Danny, OK, take this mic. OK, so we will DQ you momentarily. All right, so Danny, come on over to the middle here. And in a moment, I'm going to hand to Danny a sheet of paper that has a picture on it. And this picture is going to be something that I'd like you to verbally program the audience to draw. You can use any words, any abstractions, any level of precision that you want, but you just can't make hand gestures or sort of show them what to draw. But first, do you want to tell us a little something about yourself, including everyone here?
I'm Danny, and I took CS50.
OK, wonderful, wonderful. So I'm going to reveal the picture only to Danny. And if each of you would like to take out that sheet of paper and just make sure that no one else can see this, if you want to hold it up this way, Everyone here is now holding their pen or pencil, and in some number of steps, give them a verbal algorithm for drawing what you see. And you can say anything you want, but no hand gestures.
Okay, so you're gonna want to draw a square in the center of the paper with the diagonal pointing to the center of the edge. Wait, no, actually, I scratched that. Draw a rhombus in the center of your paper.
And for those who forget what a rhombus is,
For a diamond, a square that's on its side. And then from the bottom vertex, draw a straight line down, but not all the way to the edge of the paper. Okay, and then keep your pencil or pen at that point, and you're gonna want to draw a line that's parallel to the line of the original rhombus, to the right. And then keep your pencil or pen at that point and draw a line straight up connecting to the side vertex. Yes. And then go back to the line that you drew from the bottom vertex to the bottom of the paper, and then draw a line parallel to the left edge of the rhombus. And then keep your pencil at that point and draw a line up to the vertex of the rhombus again.
the end.
The end.
All right. Well, thank you to Danny. Hang on to your paper. Thank you so much. And if you want to step off to the stage there, we will reveal. Thank you. A round of applause, if we could, for Danny. That is not an easy task, I'm sure. And if Carter wouldn't mind just grabbing a few samples here, let's actually take a look on the overhead if we could. I'm going to pop down over here real fast. We don't need to collect them all, but if you're feeling either good or bad with what you drew, happy to collect a few of them. Okay. Oh. Okay. Thank you. Thank you. Okay. Hope you won't mind if I can't reach everyone. Just a couple more. Okay, over here. Okay. All right. That's okay. This one's really funny. Okay, I'm going to go with this one, if I may, and Carter has some too. Okay. Thank you so much. Okay, so just a random assortment here. Let me turn on a camera so I can show you what I see. Here, for instance, is one classmate's drawing, which might resemble perhaps what you drew here. Here is the beginnings of a house, it seems. Nice. This one, okay, this one is larger. And how about a couple of others that we're getting closer, I think. Okay, so more edges and vertices there. This one seems a little similar in spirit, if not proportional. This is Zach's, the best one. But it turns out, if I may, Zach, you're not all that far off. Here, Danny, is what you were reciting to everyone algorithmically. Indeed, it was this here cube. And so, Danny, can you come on back up for a moment? So, if you'd like to share for just a moment, like, what were some of the thoughts going through your head, and why did you choose the words that you did?
Okay, so what was going through my head when I saw the cube? I didn't know if I could say draw a cube. So I decided to start with the top, and so draw a rhombus in the center of your paper, and then draw a line down, and just like do the first part, then the second part, then the third part, and then you would get a cube, like Zach.
Yeah, and so had you said, and you could have said, draw a cube, which would be more of an abstraction, even that's not necessarily sufficiently precise, right? Because you don't necessarily know what the orientation of that cube is, the size of it, the positioning on the paper. So you instead took a lower level approach, which is not unlike Scratch. If you think about Scratch being able to move up, down, left, right, turn 90 degrees, turn 15 degrees, and the like, I mean, that is ultimately how a lot of graphical programs and games even might be implemented, by really focusing at the level you do. But of course, there's this tension with us humans, whereby we prefer often to think at this level, but even that might not be sufficient. Which is to say, here in week 10, like, these are still going to be and are hard problems, but a hand, if we could, one more time for Danny for getting us that far along. Thank you so much. Let me give you a stress ball here. All right, and if we could have both of our volunteers come up here. we're going to have, yes, come on up. Come on up, and let me have you guys introduce yourselves in the middle here.
Hi, I'm Evan.
Hey there, I'm Sadiq from Turkey. Nice to meet you all.
Wonderful, welcome. And this time we're going to flip it around so as to have the audience do what Danny just did for us. The only catch here is that the only means we have for showing the audience what they need to tell you to draw is like literally right above the chalkboard. So on our system here, that your eyes must stay on the chalkboard and not look up. And in just a moment, if you guys want to both stand in front of the chalkboard back to the audience, and as you're talking with each other, verbalize it through the microphone, if you will. I'm going to show everyone else in the room a second and final drawing, and we'll just go rapid fire around the room, give us one step at a time collectively, and we'll see if these guys can't draw exactly that same outcome. So,
Is there another chunk?
what's that?
Is there another chunk? Oh,
Just the one. So you'll have to collaborate, and let's give you a clean slate here, literally. All right. So, no looking up. That's the only rule for you guys. Here we go. For the audience, here is what we'd like them, ironically, to draw. Step 1 from anyone in the audience. Yes?
Draw a circle.
Draw a circle. Anywhere. Not anywhere. Okay, that's step 1. Step 2, someone else. Yeah, in the middle. Draw a line down from the bottom of the circle about halfway down. I think there was a hand in front of you, too. Number 3?
From the point on the bottom, draw a diagonal line towards the left. So the idea,
Okay.
Okay, the overarching goal here for those unable to hear is to draw a person.
Okay. It may be a stick figure.
Draw the left leg of the person, of this person. Okay, good job. All right,
Okay.
Next, step 4, yeah.
Go to the vertex of the line going up and the circle.
Okay,
And to the left, to the right, draw a V.
okay, to the right of the vertex at the
V?
bottom of the circle, draw a V.
A V.
Like what V?
Nope, not interactive. Draw a V.
Well, here would.
Right about right. We're gonna change that.
Yeah, it seems weird.
Draw a V.
Like,
Let's get ready for
maybe something like
step 5. Okay, we'll go with that. Step 5, someone else? Step 5, someone else? Someone else, yeah. Draw the right side of the leg.
Okay.
Nice. Step 6. Step 6.
Happy face.
6. 6, yes. Erase the line that you have on the left.
On the left. Okay. Yeah.
Okay, step 7, yes?
Instead of like that line that was before going up, make it go down.
Instead of that line before going up, make it go down. Okay, step 8. Step 8. Step 8. Yes? Connect that line to the hip. Not touching.
Something like this, maybe.
Okay, compromise.
Hip.
Okay.
Yeah, not touching. Okay.
All right.
Something
Step
like that.
9, almost there, I think. Step 9. Step 9, step 9. Yes, and back. Write the word high on the top left of the circle. Okay. And step 10, almost there. Draw a line pointing to high.
Okay, so it's like a speech bubble, basically.
Okay, and step 10, 11. Yeah? Erase the exclamation point. Nice. 12. Do we want to give them one more? 12, or are we good? Yep, last one. Erase the right arm. Okay, I think we're going to need a 13 then. And then? Yeah. Repeat the left arm, but rotate it by 90 degrees.
Okay. That feels wrong. Wait, how would you like, as an organic human being,
No,
how would you
no.
put your arms? Because like, would you ever structure your
That
arm like that?
would not be a stick figure.
Would you do this or would you do that?
All right, little hint maybe.
Get it. Give me a step 14.
For step 14 and final. Step 14? I think we just got to tell them what to do. Step 14. Yes?
Think of a walking mat. The right hand would be like a V, similar to a normal V, but just rotate the edge of it a little to the left.
Think of a walking man and and have the right hand walking to your right.
All right, so like, it's like,
Where could the hand go? Where should the hand go on that arm? But
what?
yeah, okay, yes, no, yeah. I mean, look right here, look right here, look right. Yes, sorry, thank you. 14 steps. That's pretty close. So congratulations to you guys, and thank you as well. All right. So I mean, these things too are not. Yes, a round of applause then. Sure. So this is to say that these ideas of abstraction and precision and really every other term of art that we explored this term are sort of omnipresent and can be easier or harder to implement depending on exactly what the problem is. But what we thought we'd do now in our final day is try to now similarly prepare you for life after CS50. And this is really going to be a list of really potential to-dos so that you can stand on your own after the class's infrastructure, write actual code, and then we'll come full circle one final time with our friend Jennifer 8Lee to look at the world of emojis and how they relate to all forms of representation that we've talked about up until now. So one, how can you go about programming after CS50? So one, you can actually install command line tools on your own Mac or PC. Perhaps unbeknownst to you, Windows has what's generally called a command prompt. Mac OS literally comes with a terminal program in your applications utilities folder. And so even if you've never run those programs, you've actually had a sort of blinking cursor, black and white prompt available to you. Might not have all of the same software installed as your code space in the cloud, but you have that command line interface even within today's graphical tools. And among the tools you can install within that command line interface would be something called Xcode on the Mac, which comes not only with a GUI, IDE, integrated development environment, but also those command line tools. And Microsoft for Windows has something similar as well. Learning Git. So we've used Git only unbeknownst to you underneath the hood for the most part, but Git is a very, very popular tool, if challenging to pick up for the first time, that makes it easy to push code to a website called GitHub or any equivalent, and then collaborate more effectively with classmates. There's definitely a bit of a learning curve, but thanks to CS50's own Brian Yu, you can start, for instance, with a video like this, and this indeed is going to be one of these de facto standards in the real world, at least for the next several years, that you'll probably encounter if you work in tech or really any company where you're doing some programming. VS Code itself will walk you through this process in the coming days, but you can indeed install it on your own Mac or PC. And what can you do when you write code? Well, you can certainly write software for your Mac, for your PC, for your phone, or of course, per week 9, you can host your own website, be it static, as in week 8, hosting it at websites like these, which generally have free or student-friendly accounts via which you can put something statically on the web at a real domain name that you might choose, or you can host a full-fledged web app. And using student tiers on Amazon and Microsoft and Google's cloud services or others, you can sign up for, being a student certainly, a whole lot of free software, free hosting, so as to, if nothing else, experiment and perhaps maximally get your own app or website up and running. So know that those are resources available to you. And this is by certainly a non-exhaustive list. If you'd like to geek out in the coming months, in the coming years, these are just some of the places that people who take computer science classes, who write code, might tend to hang out and ask and answer questions of each other. So keep an eye, for instance, on these here. And then CS50 has its own communities, as you'll see. If you go to this URL here via the OpenCourseware version of CS50, which is open to the world, is there a vibrant community, thanks to time zones, that's pretty much active 24/7, 365, talking about not only CS50 goings on and problem sets and projects, but really technology more generally as well. So certainly feel welcome to partake, either asking or answering questions. questions. Now, speaking of asking and answering questions, a couple of weeks ago, you kindly gave us a whole bunch of review questions, which we culled through and picked out our favorite 20 of them. These, of course, were multiple choice questions. And in preparation for this week, in preparation for Life Ahead, we thought we would choreograph a bit of a quiz show here. And indeed, as you came in at the start of class, you might recall being invited to go to this URL here, cs50.ly, either here in person or if you're watching live from home at this URL here. You can use a phone or a laptop. And if it's easier on a phone, you can point your camera at this 2D barcode here. We'll give folks a moment to pull that up. And again, that URL was cs50.ly/poll. And once it looks like most folks have it up and running, our friend Carter here will help us dive into this review session, if you will, with a bit of fun along the way. All right, Carter, if you'd like to take it away. What do we have as our first question? You should see on your phone or laptop this same question being asked. The first question is, how do you print, quote unquote, hello world in Python? So among the possible answers are these here. Buzz in on your phone or your laptop. We've got a few hundred responses already. 7 seconds to make your decision. This is question 1 of 20. Go into it with some confidence. I think we're down to 0 on the clock. And Carter, it looks like 98% of you indeed said hello world. And Carter, per the check mark, that's indeed the correct answer here. Now, to make things interesting, know that you'll see some number of points. And we've deliberately anonymized it, so only you know what number you are. So a whole lot of guests have a perfect score of 1,000 at the moment. Hopefully, we'll see over the next several questions things start to bridge out. But know that the speed with which you buzz in will also factor into how many points you now get. So the faster you move, the more points you get. Question 2, if we could. What does DNS stand for? From just a couple of weeks back, domain number system, domain name system, data numbering structure, or there's no such thing as DNS. A few hundred responses are in. 8 seconds remain. Fewer points now, but still a chance to buzz in. And now, as we hit 0, the responses are these: domain name system, which is indeed correct. And 84% of you got that one correctly. And indeed exists. We talked about it a couple of weeks ago. So we're still seeing a whole lot of ties at 2,000. We'll see if someone starts to pull away before long. Question 3. What is the upper bound of merge sorts runtime? So that escalated quickly. Big O of n log n, big O of log n, theta, or omega of log n, or big O of 1. What is the upper bound of merge sorts runtime? That was the last of the algorithms we saw for sorting. And in 1 second, we'll see that the correct answer is just edging out everyone else. Indeed, 46%. It is n. I know, it's n log n. Now, if I may, as the teacher, it can't be log n, because log n is strictly less than n. And you can't possibly sort n elements unless you minimally look at or touch each of them. So it's got to be at least greater than n intuitively. We still have a whole bunch of ties. Let's move on to number 4. What is stored in argc? Back to the language C. Is it an array of arguments, the maximum size of an array, the count of arguments given to a program when first run, or how much memory is allocated to a function? Again, you wrote all of these questions, and we have 5 seconds for the reveal. argc is indeed the count of arguments given to a program when first run. Think back to C. When we did command line arguments, there was argc and argv. Argv was the array, but argc was indeed the count, the C in argc. All right, we still have a whole bunch of ties at the top here, but let's move on then to number 5. What is the duck debugger's favorite hobby? According to one of your classmates. Dressing up like Dracula, swimming across the stage, filling up the entire bathroom of a guy's house, and sitting quietly on stage. The third, of course, is a reference to a YouTube video that was on the course's website that week. But according to your classmate, number 2, seconds remaining, sitting quietly on stage is its favorite pastime. So a little harder perhaps than the others. 5,000. Now we're starting to see some spread. So we only have six guests in contention for first place. And the next question now is 6. What is the function used to open a file in C? fopen, open, file. What is the function used to open a file in C? 7 seconds. There's some differences between C and Python here. And the reveal, it is indeed fopen. It's 77% correct, too. All right, let's see the rankings now. If you are guest 15, 9715, 6171, 3753, or 3273, you're now in the lead as we move on to question 7. How does Stirling compute the length of a string in C? It looks at how much memory the string uses. It counts the number of characters until it reaches \0. It counts the number of bits in the string, or it creates pointers for each character and counts them. 10 seconds. Stirling in C. Recall that we implemented this ourselves in class, but then we used the library thereafter. And indeed, with 85%, it simply counts the number of characters until it reaches that sentinel \0, aka null. And in this case, we have 5, 4. 4 of you tied now for first. All right, question 8. Where does malloc allocate memory from? The stack, the heap, the pointers, or the temp? Where does malloc allocate memory from? Responses are coming in. 8 seconds. A good review question at that. In 2 seconds, we'll see that malloc allocates memory from, close one, the heap is correct. The heap is correct. The stack, recall, is where functions store their local variables and their arguments, and that just happens automatically. The heap, represented in our pictures up top, is where malloc draws from. Now we have guest 15 has made its way to the top here, but others can catch up if they don't buzz in fast enough. So number 9. How many people flew from 50ville to New York on the day of the crime? 16, 29, 8, or 3? Anyone with a laptop perhaps has an advantage here? 5 seconds. And the answers are, but the answer is 16. Let's see if guest 15 got this. They did not. Goodbye to guest 15 at the top. All right, question 10. We're about halfway there. What are meta tags used for in HTML? To describe a web page, to define parameters for an element, to group elements together, to translate content into machine-readable format. What are meta tags used for in HTML? We saw a few of them for different use cases. And with 1 second, we see that indeed the number 1 answer was to describe the web page, be it for a mobile device, be it for screen scrapers like Facebook and Twitter and other such apps that grab images and descriptions thereof. All right, we're in the second half now. Guest 4669 has edged ahead. Guest 15 is now in 6th place. All right, number 11 is, how do you find the address of a variable in C? Think back a few weeks. Star, $, ampersand, or ask. From one of your own classmates, how do you find the address of a variable in C? And the number 1 answer is ampersand, which is indeed the address of operator at 62%. Nicely done. Let's see who's atop the list now. Guest 4669 has retained their lead, so we move on to 12. What does the arrow operator mean in C? A hyphen and a greater than sign. Nothing, starts a comment, replaces a star and dot operator, declares a pointer. What does this arrow operator mean in C? Again from a few weeks back. 3 seconds. Harder assortment, perhaps. And it, replaces a star and dot operator. The number 2 answer was indeed correct. This was just a cleaner way, syntactic sugar, for collapsing what would be a star and then some parentheses and then a dot into quite simply something that looks like an arrow itself. All right, Carter, who's in the lead now? Still that same guest. And let's see what 13 has for us. Which of these is not a data type in SQLite? Blob, string, integer, text. We used a few of these more commonly than others, but not all of these are for real. It's 5 seconds to make your decision. And the results are blob is a thing, string is not in SQLite. It's, of course, called text, as we've seen it. Blob, as goofy as it sounds, is just binary large object, but indeed it's how you might store a binary file in your database. All right. The rankings now, guest 8444 has eked ahead, so we move on to 14. Which of the following is a valid way to print exclamation point, exclamation point, exclamation point, exclamation point in Python? And I'll let you read these yourselves. Which is a valid way. Okay, everyone got quiet and is thinking. All right. 6 seconds. A few hundred responses in so far. All right. And yes, nicely done. 78% is correct. You can use the star operator to essentially multiply the character at left. All right. Who's in the lead, Carter? We now have still guest 8444. And so we move on now to 15. What does the free function do? Deallocates memory from a primitive, deallocates memory at the given pointer, terminates a loop, or returns a value from the function. What does the free function do? All right, 5 seconds. What does the free function do? It's the opposite, essentially, of malloc. And it deallocates the memory at the given pointer as well. And in C, that's on you. In Python, you don't need to worry about allocating or freeing alike. All right, we now have at the top, still guest 8444, and seeing more and more spread, 16, which is not a step of compiling. Think back now to week 2, compiling, preprocessing, linking, or threading, which is not a step of compiling. We use it as a catch-all, but it technically means a few different things collectively. All right, and threading is indeed not on the list. That is a technical thing, generally meaning a program can do multiple things at once, but that is not related here to compiling. All right, guest 8444 is still at the top. We have just a few questions left, and so 17. What was the surprise at the beginning of the Halloween lecture? According to your classmates, someone scared me, someone hid candy under every chair, someone dressed up as me, the entire staff dressed up as Carter. It's an interesting litmus test of who came to or watched lecture, perhaps. Let's see which guests got this correct. Someone's really dressed up as indeed me at 64%. So I think we have attendance here, essentially, from that lecture. So let's move on now to the final few questions after seeing that guest 8444 is still doing well. Can anyone dethrone them? Why is it incorrect to use the equals equals operator in C to compare strings? It's computationally inefficient. You're comparing the locations of the strings. Strings don't exist. Using equal equals will lead to buffer overflow. Why is it incorrect to use equal equals in C to compare strings? 3 seconds. We saw this live, and it motivated like an entire week because you're comparing the locations, that is, the addresses in memory of those same strings. All right, let's see if this leaves the rankings the same. Guest 8444 is still at the top and pulling ahead. 2 final questions. 19. What is the difference between null, 1L, and null, 2 L's? Null and null mean the same thing. Null refers to \0, whereas null, 2 L's, is the 0 address. Null is the 0 address, whereas null, 2 L's, refers to \0. Null is null, but lazier. 5 seconds. Subtle, not the best design perhaps to have in technical terms, but indeed 62% of you got that. NUL is the first thing we talked about when we talked about /0, and NULL is a pointer. It's the 0 pointer. Same thing, same number, but different context. All right, Carter, guest 8444 is the person to beat with our final 20th questions. What do the binary bulbs on stage spell today? And these are your 4 choices. Different from usual. We usually use 8-bit ASCII. Today we are using UTF-8, which is a form of Unicode, which is the larger subset that uses 1 or 2 or 3 or even 4 bytes to spell a single character. And the answer, wow, close, is indeed a cupcake. Indeed a cupcake. Well done. And let's see the final results. 8444 is the winner. Are they here in person, perhaps? 8444? You're 844. Come on down. Thank you. Here you go. Congratulations. All yours. All right. So today, if we may, give me just one moment. All right. All right, so today we are so pleased to be joined by Jennifer 8 Lee, who's an alumna of the college, a dear friend, and is actually really the reason why there's evidence of Muppets in CS50. In fact, some years ago, I was visiting her, and she had on her shelf like this custom Muppet. It wasn't one that appears on TV, but she had somehow gone on a website, a former toy store called FAO Schwartz at the time, and you're allowed to configure your own Muppet whatnot, choose the eyes, the nose, the face, and the torso, and I just thought this was the coolest thing. And so in the taxi on the way home, I was like going on the website trying to purchase our very first Muppet. I then sort of woke up the next morning thinking, why did I just buy a puppet in the back of a taxi? And so it sat on the shelf for really 2 years. And then a colleague of mine within CS50's team decided, after I brought it into the office to sit on a shelf there, to actually bring it to life. And indeed, if you Google around CS50 Muppetry and puppetry online, you'll see, in fact, these as characters, not only over the past couple of years in COVID times, when really there was next to no one actually here, and so they were instead, but indeed, she's brought not only this educational element, this pedagogical element, this playful element to CS50, and we have her here today to speak to exactly the sorts of encodings that are here on stage. Jenny is the former vice chair of the Unicode subcommittee on emoji, which is to say that she and her colleagues have been influential in taking emoji from what was a very limited character set early on and by far unrepresentative of much human emotion in speech into really an initiative now to capture digitally all of the world's languages, past, present, and future, as well as the range of emotions that we might see here in the form of that pillow or even in the cake that awaits. So allow me to introduce Jennifer 8 Lee.
Thank you. I much drink. Okay. Clicker. Hi. All right, hold on. I have to hide my drinks. I might need more water. All right. I'm really excited to speak here. Last year I was here. One, I was wearing a mask, which is like a real bummer if you're lecturing, and then the entire front part was all Muppets. So I'm really happy to see humans actually. And it's always an honor to speak at Sanders. And then Dave and I were actually classmates way back when. So I do remember him when he was an undergrad, much like you. So I'm going to give a talk on the world of emoji and how I kind of became an emoji activist. So it kind of all starts with my friend Yiying Liu, who's a designer who's well known for doing the Twitter fail whale, which was kind of laid to rest, except now this week it seems like it may be necessary again. So she and I one day were texting, this is back in 2015, we were texting about dumplings because we are Chinese-ish women and we like to text about food. And so I sent her this picture of dumplings and she was like, yum, 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 yum. And then she was like, oh, Apple doesn't have a dumpling emoji. And I was like, oh, that's kind of interesting. I didn't really think anything about it because people point things out to you all the time and then you just forget And just like move on. But then half an hour later, on my phone appears this like dumpling with hard eyes, and you don't see it in because it's a still shot, but it actually had like blinking eyes, so she liked to call it like bling bling dumpling. So she, as a designer, had decided to like go in and like make her own dumpling emoji because she was like, I'm a designer, I can fix it. But that actually got me thinking. I was like, where do emoji come from? And like, how is there not a dumpling emoji? Because from my perspective, dumplings are this kind of universal food, right? So, and there are a lot of Japanese foods on the emoji keyboard. And I was not, this was like back in 2015, I was like not a big emoji user like at all. So, I mean, you have things like ramen, you have bento boxes, you have curry, you have tempura, you even have like kind of obscure kind of foods like this thing, things on a stick, turns out to be fish things on a stick. Then this pink and white swirly thing is also a fish thing. And there's even like that triangle rice ball that looks like it's had a bikini wax, all well represented on the emoji keyboard, but no dumplings. And it's very strange because like all cultures kind of have their dumpling, right? Whether or not it's khinkali or ravioli or empanadas, like essentially everyone sort of like discovered the idea of like yummy goodness inside a carbohydrate shell, whether or not baked or fried or steamed. So I was like, okay, I literally Googled, I was like, who controls emoji? And you discover that they're actually regulated by a nonprofit called the Unicode Consortium. And it is, you know, and I just like went on their website and I discovered that they had 12 full voting members as of 2015. So this is 2015. And they were like mostly US multinational tech companies. It was Oracle, it was IBM, Microsoft, Adobe, Google, Apple, Facebook, and Yahoo. And of the three that were not multinational US tech companies, they were, let's see, a German company called SAP, a Chinese telecom company called Huawei, and then like the government of Oman. Like those were basically the 12 full voting members of the US multinational tech companies. So they at that point paid $18,000 a year to have full voting power on the Unicode committee. And I was like, oh, that's a lot of money. And I kind of felt indignant about this. And but then, like, if you kind of keep on digging on their website, you found like there was this kind of interesting loophole, which is you could join as an individual for $75. You don't get voting power, but it gave you the right to put yourself on the email list and also to like attend the quarterly Unicode meeting. So I was like, I'll do that. I had no idea what I was doing, but I'm like, I'm going to go fight for this dumpling emoji, because from my perspective, dumplings are universal, emoji are kind of universal. So the fact there was no dumpling emoji meant like something was wrong in the universe, and I was determined to fix this. So, I was on this email list, and then a couple of maybe even a couple of weeks later, I got, they kind of sent out this note that's like, hey, who's coming to the quarterly meeting? And I was like, I looked at the calendar, I looked at my schedule, I was like, oh, I'll be in Silicon Valley at that time. So I basically RSVP'd, and I was like, I will be there, and took Caltrain to an Apple building. It's a legal building in, I think it was Sunnyvale. So I just show up. And I don't know what I was sort of expecting, with the Unicode. I think maybe thought it was going to be a baby Congress, with a little, very formal seats, people with gavels. That is not what I found. Basically, it was a conference room full of people who skewed whiter, skewed older, skewed male, skewed engineers, and this is basically the room where it happened. So this is 2015. These were the people who decided your emoji. All very nice, and there was, one even had a daughter who had a sense of humor and made him a shirt that said, "Shadowy Emoji Overlord." So I just kind of listened to them debate things like milk emoji and beans emoji, and it just seemed not quite right to me that it would be this global visual language that were basically decided by a small group of people inside a conference room in Silicon Valley. So I decided to form a group called Emoji Nation, whose motto is emoji by the people for the people, and it basically advocates for more kind of representative, inclusive emoji. We started with a Kickstarter campaign, dumpling emoji process, trying to right the wrong in this world, and made this little cute video sort of advocating.
Dumplings are one of the most universal cross-cultural foods in the world. Georgia has khinkali, Japan has gyoza, Korea has mandu, Italy has ravioli. Poland has pierogi, Russia has pelmeni, Argentina has empanadas, Jewish people have kreplech, China has pot stickers, Nepal and Tibet have momos. Yet somehow, despite their popularity, there is no dumpling emoji in the standard set. Why is that? Emoji exists for pizza, tempura, sushi, spaghetti, hot dog, and now tacos, which Taco Bell takes credit for. We need to right this disparity. Dumplings are global. Emoji are global. Isn't it time we brought them together? Oh yeah, and while we're at it, how about an emoji for Chinese takeout?
So I did put together a dumpling emoji proposal. I wrote this, I remember Thanksgiving Day 2015 on a plane. And and we got it passed. Basically, dumpling, takeout box, chopsticks, and fortune cookie. I have to say, I don't think fortune cookie would have made it on its own merits, but it kind of like slid in on the coattails of the other ones. And so these were the proposals as we submitted them. And then these are the ones that kind of exist now on the Apple keyboard. And I have to say the dumpling looks really, really realistic. Oddly realistic, and whereas like the fortune cookie I think is like a big fail because first of all there's like it has no gap. It looks like a dead 3D Pac-Man. So I'm very disappointed in the manifestation of that, but that's okay. That's okay. And so it's kind of interesting. Like, what is the process of getting an emoji passed? And I will sort of walk you through it. So first of all, you come up with your idea, right? And then you kind of write this proposal, and then you submit it to the Unicode Emoji Subcommittee, who then kind of gives you comments and then sends it back to you. And you kind of go around and around in a circle. So these are things that we consider. So somewhere in there, I also like fought my way on to the Emojis Committee, and then also became a vice chair. It's sort of a extracurricular that's like completely run amok in my life. So things that matter. Popular demand is a frequently requested emoji. Multiple usages and meanings. So that's actually kind of very important for something like, certain animals have meaning. So we did, sloth a while ago, and it also has not only the literal meaning, but sort of like connotations. There are visually distinctness, it can be recognized. So this was a blocker for one of the emoji that I have worked on before, which is cave, which is kind of hard to do. I think, meaning-wise is pretty good, but it's really hard to get a cave down in emoji sizes. And then it filling a gap, completeness. So a good example for that is like for some reason for many years we had red heart, yellow heart, green heart, blue heart, purple heart, and no orange heart. So you would do the rainbow, but people would substitute the pumpkin in. So you would have a rainbow heart thing with a little pumpkin stuck in the middle. So orange heart obviously should be added and give a sense of completeness. And then something else is existing vendor compatibility. And so a good example for that was many years ago, WhatsApp decided to add the gender non-binary emoji. And then once it did that, then all of the other kind of vendors jumped on. So what kind of knocks out an emoji? So too specific or narrow. So we'll often see that with like very specific animals or a very specific group. It's redundant. So one year, oh my God, who makes the Butterball? Butterball makes the turkeys. Butterball submitted an emoji proposal that was like a cooked turkey, but we already had a live turkey. So it seemed kind of redundant to have both like a cooked turkey for Thanksgiving and a live turkey. So not visually discernible. This is a struggle for things like, I don't know, my friends have kind of proposed kimchi. Kimchi is really hard on emoji sizes for many reasons, and part of that tension is because it's not visually discernible. Then there are no logos, brands, deities, or celebrities, so no Nike swoosh, no McDonald's M. And then this is one that we kind of decided in the last year or so, which is no more flags. Flags are a very complicated thing. And as a result, Unicode does not want to be in the business of deciding what is a country or not a country. So like, when you get a proposal from like Kurdistan, you're like, yeah. So right now, the way that the emoji flags are decided is they kind of depend on what the UN recognizes. And then those get passed down to the International Standards Organization, and then Unicode just does that. Like, it does not want to be in the business of kind of, the geopolitical affairs. So once it comes out of the subcommittee, it goes to the full Unicode Technical Committee, UTC. Those are the people that were in the room that I showed you. And they vote once a year, basically, to pass all the emoji. And it takes a while. There's a lot of like coordinating with the International Standards Organization and like a lot of working with the companies. And eventually, it takes a long time, but it ends up on your devices. And that historically has taken about 18 to 24 months from when you put in a proposal to when you get it in. It's going to be a little bit longer going forward, probably, is my sense, as Unicode has decided to sort of space out some of the Unicode releases. So yeah, Emoji Nation, kind of has done its thing. So one of the weird things is like, how did Unicode, this like kind of nonprofit organization based in Mountain View, California, end up controlling this like global visual language? So a lot of it has to do with the fact that emoji started in Japan back in the late 1990s. This set from Docomo in 1999 is widely considered sort of like the first like color emoji set. It has been collected by the Museum of Modern Art. And so the Japanese telecom companies would have their own sets of emoji, and then there were different companies, so they would have different sets. So you could basically only send these like visual characters with someone who was on your same carrier. So it's like basically equivalent of if you were on like Verizon, you could only text people on Verizon with like emoji, or if you were on T-Mobile, you could only do that. So at a certain point, they decided the Apple and Google came into Japan. They wanted to start selling smartphones, and they realized that it was a hodgepodge of systems, and they wanted to unify it. And so in 2007, they went to Unicode, and they're like, okay, help us unify the emoji, basically all the emojis so that we have one standard system. And part of the reason is why Unicode? Because Unicode basically has this mission, is to enable everyone speaking every language on Earth to be able to use their languages on computer and smartphone. So it basically unifies all written languages into one ginormous set. And that was not the case, actually, when I was growing up. There was a point where, like, if you were Japanese on Apple, that would be different than Japanese on DOS, or like Chinese or Arabic. So it drove everyone crazy, and they basically decided around the late 80s or early 1990s that they were going to come up with one standardized system that sort of encoded all characters in one ginormous set. So there's three main projects for Unicode, if you care. So one is encoding characters, including emoji. Now there are about 100,000 characters assigned. So that includes like Chinese, Japanese, Korean, Arabic, Cyrillic, actually all the hieroglyphics, all of the emoji, a lot of things like the Bitcoin symbol or like copyleft or whatever. Those all assigned were about 100,000 characters, even those languages that are basically out of use. So the other thing it does, it creates localization resources. So things so that you know, like, oh, if you're in this country, you're using the euro, or you're using the pesos or something. So there's a lot of localization that data that is needed depending on which geography you're using your device from, or like that, you know that the time is used this way, or dates are shown that way. So that is called the Common Locale Data Repository, or CLDR as they call it. And the other thing they do is they kind of maintain libraries for developers in order to do all so they are not building everything from scratch, and that is called ICU. So it's very funny, because like it's called CLDR, and then one day, one of our friend's girlfriends made him this thing, which she called a seal deer, because whenever he talked about CLDR, she thought he was talking about seal deers. So now this is his little like mascot for like Unicode related things. So how does Unicode do this? So it basically assigns code points, and each code point is a unique number assigned to each Unicode character. So Face with Tears of Joy can be written like this with a code point, or it can be written like this in terms of decimal numbers, and it can also be written this in binary numbers. So these are all basically the same. And the key thing to know, at least about emoji, is that when your device, if you're talking your iPhone with someone who's on a laptop or an iPad or like on an Android device, it's not sending the images back and forth, it's sending just a number back and forth. And then locally, your phone or like your laptop decides like, oh, this number correlates with which image in terms of our emoji font, and then pulls it up. So this is really key to know why different emoji look different on different platforms. So 2007 to 2010, it took about 3 years, but Unicode 6.0 came out with our first little baby set of emoji. And it just kind of hung out there for a year. Like it wasn't doing anything. So 2011 though, Apple starts adding the emoji keyboard and it just like explodes. Like I feel like in some ways emoji were not like invented, they were discovered. They like obviously touch something very, very primal to like our human desire to like communicate in like little colorful glyphs on electronic devices. And you kind of have, what's kind of really interesting is like the ambiguity that comes with what emoji kind of mean. And so one of the, this is one of my favorite emoji. It's sort of like an upside down smiley face, very, very ambiguous, clearly very ambiguous, because if you start typing into Google, like the top hits are like, what does it mean from a guy? What does it mean from a girl? Like it's clearly something that a lot of people are using in like complex situationships between each other. So, so one of the fun things is who can propose emoji. Technically, anyone can. Anyone here can. Normal humans can. We have basically Google Doc or Google Form that we throw up historically between April and August in the last 2 years. So this is one of our favorite examples. This is Rayouf Al-Humaidi. She was a 15-year-old Saudi Arabian girl who was living in Vienna at the time that she proposed the hijab emoji. And then, then she was like Time Magazine, like, coolest teens. She got like a whole bunch of different things. She got into Harvard and Stanford, and she went to Stanford. So this is a proposal we got. Then there was a group of folks from Argentina who got the mate emoji, kind of, sort of similar to their national drink. Then we worked with, there was a nonprofit that really wanted to like get a menstruation emoji, and so what they proposed to begin with was like bloody underwear, and I was just like, no, so many different reasons why this is a terrible emoji. But so we did get blood drops, and then you could do moon and blood drop, or underwear and blood drop. There's a lot of different ways. Actually, it's really funny because I was polling my friends beforehand what they would use to indicate menstruation before there was a blood drop. So there was like red wine. There was like kind of that rose with the like falling petal. And then my favorite is actually my friend who used the Japanese flag as a way to indicate that she was having her period. So one of the biggest contributors, this skin tone emoji, appeared I think in 2015. It was amazing. And it was proposed by a mom, Katrina Parrott. She is an entrepreneur and a mom who was just like at home one day, and her daughter comes home and is like, I wish there were emoji that looked like me. And her mom was like, that's great, honey. What's an emoji? And so she, like me, I guess, Googled and just figured out that Unicode controlled emoji, and she just came up with a proposal saying we should not only have the yellow skin tones. At that time, everything was sort of Simpsons yellow. It's really interesting to see how race and like nationality are like depicted in different parts of the world. So originally in Japan, everyone was yellow, but these were the by default, everyone was just like human or Japanese, but they had like a couple things that were like not. Like one was you had a blonde person, so there's an emoji called like blonde woman or whatever that represents all Westerners. Okay, so that was one. And then they have one that's like an Indian guy with a turban, so that's supposed to represent Indian people. And then there's like a guy with a little little hat that's supposed to represent like Chinese people. So that was the Japanese view of race, which was like default. Then you were like blonde Western, Chinese, or Indian, and that is all there was. And obviously in the United States, we care a lot about race, and then so she came up with a system with 5 skin tones. Just like normal people. Some guy in Germany decided that he wanted to do a face with one eyebrow raised, or as we call it, the Colbert emoji. This one's fun. So woman's flat shoe. I have to say, not highly used statistically at this point, but I really kind of appreciate it because it was a mom who was very offended that all women's shoes had heels, even the sandals. So this is her. She had like 3 kids at the time. She now has 4. She was very fertile. And she also did the women's flat. Okay, she also did one-piece bathing suit because she was also offended by the fact that the only kind of bathing suit you had was like this like little itsy bitsy polka dot bikini thing, which is not great if you're like taking your 6-year-old. So I have to say that got passed, but like it didn't go over like super well with everyone. So you know, Unicode, because it's very public, submits things for comments. And we got this comment back. So one-piece bathing suit. Why? A person wanting to indicate the use of swimwear can't use existing bikini? Is this really necessary? What about a Victorian bathing costume or a wetsuit or water wings? This is like literally in like the records. And I do not encode. And so the person who did this is actually very impressive. He's actually the person who created the middle finger emoji. And actually, if you've ever seen the Vulcan emoji, the Vulcan hand emoji, he's actually very active. And I have to say, this is actually, I think, one of the more impressive emojis. So obviously, we have a lot of active debate. Sometimes you get like whole countries submitting. So literally the government of Finland, as in like their equivalent of the State Department, their diplomacy kind of thing, submitted a proposal for sauna. And these were so creepy and so weird. So much is wrong with this. But I felt where they were coming from. First of all, like, they're naked. They have club feet. And so we decided to help them. We're like, okay, we see where you're going with this. Let's see if we can like help you like come up, like we had the spoon, like should there be like steam around them, like should they be naked or wearing a towel? It was like super like dicey, but we wanted to help them because it was like literally a foreign government coming in front of Unicode advocating for the sauna emoji on behalf of their entire country. So then this is, it sort of evolved into just basically person in steamy room, which is the most sort of like the PG version of sauna. No, and there's no spoon, they're all dressed, it's very odd. But so you can see the evolution of what it started out, what we submitted, and then what it ended up. So there's a lot of like evolution throughout the entire process. And like companies can submit emoji proposals too. So Google actually worked on this one. I love this one. Okay. So just to give you some context, as of 2015, there are many ways you could be or have an occupation as a male on the emoji keyboard, right? Like for example, you could be a police officer. You could be a detective, you could be a Buckingham Palace guard, you could even be Santa Claus. Like these are so many jobs that you could have. But if you were a woman, as of 2015, there were 4 things that you could be. You could be a princess, you could be a bride, you could be a dancer, or you could be a Playboy bunny. These were the sum total of all the occupations that we could have. So there was sort of this movement at that time. There was like this like video on YouTube that like went viral. There was like a New York Times op-ed that was like, where are the women with professions? So basically they came up with a set of emoji for professions. And what's nice is not only did women have these professions, now men have them too. So of Emoji Nation emoji, these are some of the ones that we've worked on. I think about 130 of the emoji on your keyboard probably came through, touched our system in some way, including, I have to say, microbe or virus. I think I have the opinion that every emoji has its day, right? Like it might not be like today, it might not be next year, but I have to say virus was not doing anything. Then came 2020, and that was like such a good moment for it. Along with soap, we had also done soap. So, among the other emoji that we have worked on are starry, mooncake, llama, like teddy bear. There were no toys. I felt really sad for toys. We have like giraffe. There was hut. Bubble tea. Bubble tea was very controversial, actually. I have to say, we tried to slide it in originally with the takeout box and the dumplings, and people were not having it. And I understand that because there's not a lot, like compared to like beer or wine, like bubble tea does not have a long history on this planet. But I will say that they submitted again, actually kind of originally proposing that it was not just bubble tea, but like a black ball and milk and tea. It was kind of cool. And I have to say there was definitely a generational divide between like the Asian women who sit in that room and are like, this absolutely is a thing that we consume like almost like every week of our life. And people who are a little bit older who are like, that looks like a parfait. How do you not know that's a parfait? And we're like, we absolutely know it is not a parfait. And so it got in eventually. So it does sort of influence, it kind of shows like who is in the room influences, the decisions that get made, or sometimes in the room, now sometimes more likely in the Zoom. I actually had to say beaver emoji. If you see beaver emoji, that's one of the ones I'm most proud of. So that is actually co-authored by a professor here at Harvard, who is both lesbian and was married to a woman from Canada. So it was very important to her to get the beaver emoji passed. And she promised me it would always be the first line of her bio. So, and indeed, if you go to her Twitter handle, it's like Joan Donovan, creator of the beaver emoji, comma, is head of research at the Shorenstein Center at the Harvard Kennedy School. It's pretty impressive. And then we did greens. Actually, greens was really interesting because people, this was also like a generational cultural thing. People were like, why do we need greens? We have salad. And I was like, we're Chinese, we don't eat raw greens because like you don't know where it's been or if it's clean. So we cook our greens, so salad is not something that we have. So eventually I got my greens, and so that was kind of fun. And then, so these are some of the people who sort of have contributed to our little Emoji Nation things, including a number of Native Americans who helped get feathered. So why do I care? So part of it is because I'm Chinese. I grew up speaking Chinese and English at the same time. And it's really interesting to see like Chinese and English characters in terms of emoji and Chinese together, right? So this is fire, you have like fire characters, and now you have the emoji things. And it kind of shows that there is a longevity in the human experience of something that was designed 4,000 years ago has the same visual cues in the human experiences as now. So mouth, tree, moon, sun. You can mix and match them, which is super fun. So, you know, 2 trees, kind of make a forest. Oops, sorry. Oh, well, okay. Then the moon and sun together means bright, which I like. I like this one. So if you stop and you think about this, so this is basically a pig under a roof. And what does that mean? It does not mean farm, as you might think. It actually means home or family. So in the Chinese kind of structure and outlook on the view, it's like where you keep your pigs is actually where your home is and what your farm is. So it gets kind of weird in all kinds of ways. So one of my favorite radicals, so this character means woman, ni, and as I was learning Chinese, you kind of notice like how it shows up. So this is a woman underneath a roof, and you're like, oh, it means mom or wife or like whatever, like home. It does not. It means peace, because things are at home when the woman is, or things are at peace when the woman is at home underneath a roof, which I always thought was a little bit odd. Then there is also woman plus child. So you're like, oh, and actually specifically boy child, the connotation there is a little bit unclear. So you're like woman plus child, family, mom, you know, whatever. It is not, it means good. So the standard for goodness in ancient China was a woman who had a male child. So that kind of just like kind of irked me growing up. And then, you know, 3 women together means evil, which is like very like Macbeth. This character means greed. This character means slave. This marriage, let's see, I think this one is jealousy, and this means adultery or betrayal. So, like, definitely not loving the way women were portrayed on the emoji keyboard. So, in case you're wondering, we just came out with a kids book called Hanmoji that kind of compares emoji and Chinese, and I think they sent out a bunch of books so that you guys can do some kind of contest, like later on with CS50. But the mixing and matching is really interesting, right? For example, the skin tones are actually the same yellow character plus a layer of skin tone on top of this. So I kind of took my lessons from Chinese in terms of seeing how things can be bind. So there's something you should know about, which is Zwij. This is also an invisible emoji character. It stands for zero with joiner. And it was actually originally created mostly for, I think, Arabic, where you would basically kind of force something to have like be in the beginning of a word or an end of a word by kind of having this like invisible character. So the rainbow flag, for example, is actually a rainbow plus the white flag. And we could have all kinds of fun combinations. If you look at polar bear, it actually is, if you have an older device or it breaks apart, it is bear plus snow, which is really cute. It was, originally I had bear plus white, and then we decided that bear plus snow made a lot more sense. So another one, this is new, I think you guys should have it if you've updated your phones in the last year or so. So mending heart is heart plus Band-Aid. What is this one? Oh, this is interesting. There was a breastfeeding woman for a long time, and people felt like there was not gender parity. It was actually really interesting. All the people who wrote in and were like, I want to be a dad showing that I'm holding my baby. Why is there only a woman holding my baby? So we kind of created a whole set. So this is man plus model. Ta-da! And so this is, and all of these occupations are actually oftentimes a woman plus, like, you know, the fried egg, or like a school or a tractor, and that's how you got the occupations. If you send an emoji over into an older system, sometimes it'll break apart. So one of my kind of favorite kind of contributions in this world is interracial couple emoji, which we did with Tinder, which is super fun, because then you could have, you know, different couples that are, and like so many combinatoric. This is a fun, if you guys ever have to do a combinatoric test, this is really fun, because you have 2 genders plus a third neutral gender plus 2 people plus 5 skin tones plus yellow. Like, how many emoji couples can you come up with when you introduce this factor? So this is, and underneath it, it's just a Zwidge sequence. It's like 2 people standing together that are like glued together. Now, this actually gets interesting from a CS50 perspective, because in many cases, even though you only see one character, underneath the hood, depending on how your system works, they're counting each one of these as an individual character. So your string length actually might be 5 instead of 1. And this kind of became a problem with things like Twitter, where things had a hard skin length. So gender inclusivity is actually one of the things that we've been dealing most with in the last couple years. So it's kind of interesting if you think about both what a pictorial language looks like versus the abstractness of a spoken language. So, because, you know, we had boy and we had girl, but there was no way to say generic child, right? Like, if you wanted to say child, you had to pick a boy or a girl, but not a way to say like just some little person. And that's really key, because in English, at least, there is no gender implied by child. So how do we mimic that? And it also is key for something like doctor, right? Doctor and teacher, those don't have gender implied, but when we have them on the emoji keyboard, you have to pick a male teacher or you know, a female doctor or whatnot. So there was actually a guy at Adobe who considers himself non-gender binary. Also, the man behind the orange heart, he fought and got basically the first 3 non-gender binary emojis. So child, adult, and older adult. So those are created. And then we started having to propagate them through actually all the occupations. So these are the gender neutral versions of many of those. But then we got into this whole thing where every emoji that had a gender originally had to be mirrored. So originally we had bearded man, and then we're like, okay, well, we actually have to get bearded woman. So that is on your keyboard. There is pregnant woman. There is now pregnant man, which is interesting. There is, you know, woman in a bridal gown. There's now man in a bridal gown. And then there were ones that actually had to be created that were neither man or woman. So this is a mer person. So there was merman, there's mermaid, and there was mer person. It was really interesting to figure out, like, how do you draw a gender neutral mer person? Like, a bunch of them in the beginning actually had the arms crossed around sort of the chest. Monarch, so there was prince and princess, and now there is monarch. And one of my favorite actually is there was Santa Claus, and there was Mrs. Claus, and now there's MX Claus. Like, the name of this character literally in Unicode is MX Claus. So I feel like it's sort of like a very official enshrining of gender non-binariness in like the world. Not everyone loved it. New York Post did not love this. They're like, you know, we're getting into like emoji woke wars. So some emoji stats for you. This is very fascinating. This is sort of like the general distribution. By far, the single emoji that you use more than anything else is the face with tears of joy. About 10% of all emoji sent is that one character. And then number 2 is heart, red heart. And then it kind of goes down. So there's a frequency of emoji use. This is sort of done by order of magnitude. So 1 is half of 2, 2 is half of 1, da, 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 da. So it's really interesting. It's a very, very steep drop off after the first couple. In case you ever want to go onto the emoji kind of Unicode website, you too can see all the frequency things. So I think it's really funny. So basically, if it's green going this way, it increased in usage between 2019 and 2021. If it's red going this way, it dropped. And so pleading face, which was a relatively new emoji, just sort of shot up on the charts. And whereas actually like smiling face with heart eyes actually like kind of slipped, which is interesting. So we just closed our emoji proposal round for 2022. These were sort of the breakdowns. People love submitting smileys and food and beverages, animals and nature, I mean, these are very googly colors. So what is the future of emoji? I will tell you, because we just had a meeting 2 weeks ago, so I can now publicly talk about it. So historically, there was this whole idea, like Unicode doesn't want to be in the world of like encoding glyphs for like devices everywhere. Like there was very controversial when it started doing that, because mostly what Unicode used to do was we take an existing language, could be dead, you know, and then it would just take it and digitize it, right? It took languages that existed and just digitized them. And then when it kind of wandered into emoji world, suddenly it's like deciding what deserves to be like an emoji, decides to be digitized. So trying to get out of it, and they have proposals over time where it's like, oh, maybe we should like come up with a way to just send pictures back and forth where it's a fixed picture and you like use a hash so that you know, like we would look at the picture and then like go do a lookup somewhere. Like that did not go over well. Then there was actually a really interesting proposal I kind of like, didn't go over well, which is using something called the QID, which is in the Wikipedia world. So in Wikipedia world, items all have numbers across the different language Wikipedia. So Obama, human, Earth, they will have an ID number so that the page in English and the page in German and the page in Chinese all know that they're pointing to the same thing. So so one idea came up, like, why don't we use a numbering system? So we can use like Eiffel Tower and, you know, see the number, and then like, oh, people know like, oh, you're trying to say Eiffel Tower. That did not go over well. So those are both of those proposals seem dead as of yet. And it's too bad, because you'll see kind of what's happening. Okay, so what's coming in 2022? So these are the emoji that I actually sort of thought they would be on your phones by now, but because we're in mid-November and they usually update early November. So 3 more hearts. People love hearts, like wing, blackbird, goose, birds also, purple flowers, jellyfish, moose-faced donkey. Donkey was a little bit late for the kind of elections. Ginger, pea pod, wireless, conda, shaking face. Folding hand fan, that one was interesting, because when people first proposed it, they proposed it as like an electric fan, and that didn't, like, who knows what electric fans will look like in 100 years? Because the thing is, once an emoji, always an emoji. They never retire. So they're always looking for things that have a visual longevity. Floppy disk did not actually do that. So there's always like, we don't want another floppy disk. And then hair pick is interesting. So there was a whole debate about how to convey like African hair. Like the curly hair that they introduced a couple years ago was supposed to do that, and most of the vendors actually have it in a sort of Afro-y way, except for Apple. So there's a lot of complaints, but hair pick was sort of an interesting way. It means both comb, but also has sort of an interesting historic connotation, and it's been around for about 2,000 years. A couple of music things, maracas and flute. Beyond 2022, one of the things that's gonna die, oops, can I go back? No, I can't. Oh well. We're going to retire the family emoji. They didn't go over so well. There were so many of them. Combinatorically, if you had everything in you know, all the races, because you wanted to have skin tones, because you didn't want to imply that families can only be one race. It was such an ordeal. Essentially, we're all like, no one uses them, and there's so many, and it's like the fonts, like in terms of the load, is like too large. So they're just going to make them all into like basically little like bathroom symbol type folks. So I think those will disappear. What's actually really interesting about the family emoji is they had when they introduced the family emoji, they had gay family emoji, and the Russian government went berserk. And actually, you can Google this in 2015, you'll see a bunch of articles about like the Russian government considering it homosexual propaganda to youth, and there was a big debate about whether or not they were going to ban Apple devices and whatever. So you can see a lot of the media coverage from that time, but I thought it was really interesting how upset a national government can get about little pictures on your phone. Another thing that's on the agenda as of a couple of weeks ago is directionality in terms of emoji. So as you know, most emoji kind of just flip one way or another. And the reason why it matters is because not all languages run in the same direction. So for example, Arabic. So we are used to left to right, but a lot of languages go right to left. And this kind of changes the meaning of emoji. For example, right to left. I send this a lot to my friends when I'm flying from the Bay Area to New York. If you do it from left to right, however, that is what it looks like. So it looks like, you know, you're in the Bay Area, but the plane is still going that, you know, kind of up and to the right. And then now it looks like you're going from New York to the Bay Area. The other place is like, oh, it's a girl and she's running really fast, right? That is right to left in our world. Wait, left to right, sorry. That's supposed to be left to right. And in here, it would be, she's like behind like pollution or something like that. So sorry about it. So an example, this is actually in the proposal. Like in one case, if it's left to right, you're running away from a line of cars. In the other one, it's a warning to not run behind car fumes. So they are trying to figure out like how do we mirror a bunch of the emoji. But the main thing that I think sort of, I don't know when it's going to happen, I'm really hopeful it's going to happen, is trying to come up with a system that it supports little stickers in line that don't need Unicode. So this is like Slack or on Twitch. You can embed little pictures in line, and all the vendors have to get together and agree to come up with a standard way to do that. They have not yet come up with that, but that is sort of one of the ways that Unicode like wants to back away from actually being like a global regulator for like little colorful glyphs. And so if you ever need to reach me in my emoji world, you can find me, Jenny@emojination.org. There will be it will be actually a while, I think, before we see a next generation of emoji showing up in keyboard. It used to be like every year they would get new code points. It might be a little bit less than every year now as they work on things like directionality over time. So that, if anyone has questions, you can ask questions. You can find me afterwards. I think I feel like there's supposed to be some hubbub right now about maybe microphones, but maybe not, but maybe I'm just done. And if there are questions or if David is around, I'm happy, you know, I'm happy to answer any questions that folks have. Yes? Yes?
I was wondering, what were your thoughts on like the Emoji Movie?
So the question is, what are my thoughts on the Emoji Movie? You're talking about the Sony animated one. Yes. Okay, my thought on that is it is better than a 6% rating on Rotten Tomatoes would lead you to believe. So that's my one thought. And my next thought is that that was a rush job from an animation perspective. That was about 18 months of, whereas a typical animated movie takes 4 years. So in my spare time, I also produce movies and documentaries. So one thing that is key to know about movies and animated movies, and this is very important, they take a very long time, but you can always fix it because you haven't shot anything. And a very good example of that is, I assume you guys have seen Frozen. If you haven't seen Frozen, you seem of the age that you would have seen Frozen. I do not understand like how huge and a phenomenon or why it was such a huge phenomenon, but they actually did an original cut of Frozen, and it did, so I don't know if you guys know the sort of Snow Queen thing, but she's like super dark and like not fun and like kind of evil and like not someone you want to like get behind as a character. So they actually did sort of a rough cut of that, of Frozen, and they came out of that with, it's just storyboarding, and they were like, that is not good, and they killed it. So they were like, we can't go with this, and then started from scratch, more or less again, starting with the song Let It Go, which is actually written by a kid from my elementary school, Bobby Lopez, or co-written by Bobby Lopez. I also, actually, fun fact, I took the school bus with Lin-Manuel Miranda. So I was a 4th grader when he was like a kindergartner. So we had a very musical elementary school in New York City. But the thing is, they could fix it because they had enough time and have enough money. Not like movies where you shoot humans, much harder to fix because you have the footage that you have and you can do little pickups, but you can't fix it. So essentially what happened in that case, I think, it's 18 months, and it could have gotten better. And a lot of the movies that you see with Pixar, like it's actually sort of emotionally similar to the movie called Inside Out. And but Inside, they just have more time, and so it's better. So as opposed to 18 months, which is not long enough to make animated movie good. But the other fun thing is it was so weird because they sold sponsorships. It was like. Oh my God, here comes the bots and the malware. Let's go into Dropbox and protect ourselves. And so I think that it got a lot of like bad kind of vibes from the press for doing things like that. But from a kid's perspective, it's fine. I think if I don't know that I would like put it on my top 10 of animated pictures, but it's better than 6% on Rotten Tomatoes. And then actually, if you guys ever care, we have done, I did a documentary about emoji, and all the people that helped create emoji, and we did a CS50X movie night, I think, during the pandemic. Was it during the pandemic? Everything's sort of like blurred together, but it was during the pandemic. Yeah. Are we, more questions? Yes. Where there's demand, yeah. Yeah, that's a very good question. Yeah, so the question is, one of our criteria of getting an emoji accepted is to sort of demonstrate demand. And how do we demonstrate demand? And I would say it's in a pretty clumsy way, actually, at this point. So the main thing that you have in our current proposal process is we have a median emoji, which is elephant. So elephant is like, if you stack ranked all the emoji for popularity, elephant is like right there in the middle. And it's also a concept that's like universally understood across all languages. So elephant shows up somewhere between 500 million and 700 million in Google search results. Like if you type it into a laptop, you'll see, elephant, 500 million search results. And generally you're trying to, when you're comparing your term to elephant, you want to see very roughly how many Google search results, Bing search results, sometimes Instagram. So actually something that was really surprising to me was someone proposed hummingbird. I think hummingbird is a good proposal. And, but if you look at hummingbird, it's only like 21 million in terms of the stats, so, which I thought was like very surprisingly low. So that's one of the main ways that we kind of see like, is it also visually used and all of that, yeah. Any other questions? Are we good? I didn't even need my water or anything. Oh, and I'm gonna take a picture. I'm gonna take a picture because now you guys are actually human and not Muppets, so I'm very, very excited about this. So I will send this to like my blockmates and be like, I just lectured at in Sanders Theater.
Well, my thanks to Jenny Lee. Thank you. Yeah, you can stay up here if you want. Give me 1 second. So if up until now, thought it would be appropriate to toss this up on the board. If up until now you've not yet gotten a CS50 stress ball on the way out, please do grab one. We got some extras as well off to the side. But I would also keep in mind back in week 0, where again we began, we asked you to categorize yourselves as to whether you are among those less comfortable, those more comfortable, or those somewhere in between. Please know now that you are officially all Please know now that you are all officially among those more comfortable, and indeed, even though a couple of more milestones await, we cannot wait to see what you accomplish with your final projects. In the meantime, as always, this is, and now, this was CS50.
Mr. Sandman, when I enrolled in CS50, I'll say truth be told, I thought I'd be a real coding hero because I did so well on VSET 0. Sandman, it picked up so fast. Turns out that C is harder than Scratch. Hello world and goodbye sleep, because this is CS50. Mr. Sandman, I was on the Val grind, trying so hard to not fall behind, attending section and wanting a tutor, stuck in the inch-main void of my computer. Sandman, finally getting ahead, then Malin switches to Python instead. Why we spend 5 weeks on C? Because this is CS50. Mr. Sandman, we completed each task. JavaScript, SQL, CSS, and Flask. With every language, our minds had to reset. Don't get us started on that finance piece, Sandman. Now on week 10, my friends asked if I would do it again. I replied, obviously, because this was CS. No more pieces, because this was CS5. T.
So this is CS50. My name is David Malin, and this is Harvard University's Introduction to the Intellectual Enterprises of Computer Science and the Art of Programming. And this, of course, is our special family weekend, wherein not only are CS50's own students here in the audience, but also some family members as well. Now, you're showing up in the semester a little bit late. We've just tackled week 8, which is really our 9th week since computer scientists start counting from 0. So we've done a whole lot of work over the past few weeks, as you might have heard via emails or text messages home, including a language known here as binary. So on the screen here, of course, is a lot of zeros and ones. And suffice it to say, let me sum up the past 9 weeks with this is what's going on underneath the hood. But of course, today we thought we'd make things a little more accessible, a little more broadly applicable. And indeed, our focus today will not be on what these patterns of zeros and ones represent, which an astute eye might notice are replicated visually with these light bulbs being in a pattern on and off. And as your child might have hinted before class, or perhaps now, this might very well spell a word up to 8 characters long, because you can encode, even in the real world, things digital too. But today we'll focus on things much more high level, this notion of cybersecurity, like the security of our data, our privacy of our systems, particularly on the internet nowadays, because presumably all of us are carrying technologies around in our pocket, using laptops and desktops every day. And so the goal today is to stipulate that this is what's going on underneath the hood, but let's solve some problems at a higher level so that your homework, when you go back to wherever you're visiting from, can actually be to apply some of today's lessons learned. So with that said, perhaps the most common familiar defense of one's systems and data, phone and laptops and desktops would just be these simple passwords. Unfortunately, you and I are, frankly, as humans, not all that good at choosing passwords. And this is in itself a relatively weak form of defense, even though each of us has dozens, hundreds of passwords nowadays, or at least dozens or hundreds of accounts, maybe 5s or 10s of dozens of passwords. Indeed, if you're in the habit of reusing passwords, we'll see today, probably among our first lessons learned. So for instance, if we look back at the past year, 2021, thanks to security researchers who take a look at data that has been hacked or leaked online by way of public databases, we have a sense as computer scientists of what the most popular, or equivalently, what some of the worst passwords are that you and I are choosing for our system. So as of this past year, according to one measure, the most commonly used password in systems everywhere was 123456. All right, so number 2 password in our top 10 here list was only slightly longer, 12345678 After that, we took a turn in the other direction, 12345 alone. After that, got a little more interesting, QWERTY, which might sound pretty cryptic, but not if you look down at your US keyboard and it's the top left-hand row of the keys on an American keyboard. So also not all that hard. Perhaps not surprisingly, a little disconcertingly, number 5 was password. Meanwhile, number 6 returns us to digits, 1, 2, 3, 4, 5, 6, 7, 8. After that, really less effort, 111, 111. After that, a little more variation, but not all that much. 1, 2, 3, 1, 2, 3. After that, it's getting even less interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then lastly, topping the list is just 1, 2, 3, 4, 5, 6, 7. So this is not a good top 10 list to be on. So among today's first takeaways is if you see your password on the screen, like you didn't make the list in a good way, this means hundreds, thousands, millions of other people probably have that password of yours. Now, in and of itself, that's not necessarily worrisome because I don't know who has these passwords in a room as large as this, but just intuitively, why is this a bad thing? Either parent or child. Welcome to raise a hand here. Why might this be intuitively? Yeah. So access to it, like, I mean, we literally, as computer scientists now, have a database of really common passwords. And your thoughts? Yeah, you can just find it out quickly. I mean, you could imagine trying to guess someone's password by just typing in random letters, random numbers, random words. But not if you have a top 10 list. Like the adversaries in the world might as well just start with this list. Now, you'll notice that even absent from this are slight variants. Like some of you might be thinking, I'm not on the list because I do something clever. Like I use an exclamation point for the number 1, or a 3 for an E, or a 5 for an S. And based on the smiles in the room right now, you're not all that clever, it turns out, because other people are smiling too, which is to say that an adversary can take those same heuristics that you might think are making things more secure by just tweaking some letters to numbers or vice versa. But if you're doing it and other people are doing it, the bad guys, so to speak, are going to be doing it as well. So unfortunately, when it comes to passwords, better is longer and random and really unguessable, but that's not what most of us have. In fact, case in point, on our phones, whether you have an Android device or an iPhone nowadays, odds are you have something relatively simplistic protecting it, if you have anything at all. But at least Apple and Google are pretty good at least nudging us to choose these kinds of passcodes now. And a 4-digit passcode is quite common nowadays. And so here's where we have an opportunity, thanks to the URL that you saw on the screen earlier, to conjecture as a group just how long might it take an adversary, someone out there who's out to get us or get one of us, how long might it take an adversary to figure out your phone's 4-digit passcode? This is CS50's own Carter. Carter, if we could switch over and poll the audience here. If you take out your phone or laptop, whatever device you might have used a few minutes ago to scan that QR code or to visit that same URL, you can see these questions on your browser. And if you can't, that's fine. We'll share some aggregate data nonetheless. But you should have an opportunity to tap one of your answers. And we'll give folks a few more seconds if you'd like to play along at home. And here, in just a moment, probably have many people reporting. But why don't we go ahead and take a look at some percentages. It looks like most of you, 67%, are proposing just a few seconds. So that's not all that good news if it's a 4-digit passcode. Some of you are hoping it's a few minutes. 8% are hoping a few hours. More than 4% of you are really hoping perhaps it's a few days. Well, let's actually consider how we can answer this question and make today not just conceptual, but a little quantitative too, and see if we can't slap some numbers on questions like these. So ultimately, you can make more informed decisions with your system's security. So for instance, when it comes to 4-digit passcodes, rather than just consider how secure it is, well, let's make it a more precise question. Like, what are the forms of attack? Well, the simplest attack might be just someone grabbing your phone, be it in your family or maybe at Starbucks or the airport or the like, and just starting all possible combinations, maybe 0000. then 0001, and 0002. We could maybe automate this a little bit. So for instance, I might potentially be able to do something like roboticize this here. Let me go ahead and full screen a quick video here that's just going to paint a picture in just a moment on the screen of how if we're a really clever adversary and know how to build things, well, at least maybe we could automate some of that process. So here's an Android phone sitting on a counter. Here's a very simple tripod and a little touch device robotically doing all of that hacking for you, starting at 0000, probably all the way up to 9999. Now, that too wasn't necessarily all that fast, but at least the adversary can step away and doesn't actually have to be bothered with the time involved, the cost involved in actually hacking that particular device. Well, let's go one level deeper, a little more interestingly, and consider here how much time really this so-called brute force attack would take. And that's actually a term of art, much like in yesteryear when maybe there was a battering ram trying to brute force their way into a castle or something like that. A brute force attack digitally is just someone trying manually all possible codes, or maybe robotically trying all possible codes, but generally automating the process in some way to go through all possibilities. Well, if you've got, for instance, a 4-digit passcode, let's ask maybe a follow-up question here. Not how long it will take, but how many possible 4-digit passcodes are there? Because then maybe we can do some quick math. And if every passcode takes me a second or a few milliseconds or the like, then I think we can try to extrapolate from that whether the first answer was seconds or minutes or days or hours or something else. So how many 4-digit passcodes are possible? If you take out your same device, it should have just changed automatically. If it doesn't seem to have, maybe reload your browser with some menu option. And then tap in here. How many 4-digit passcodes are possible? 4 total, 40, 9,999, 10,000, or unsure is OK too. So let's see. We'll give you a few more moments. How many 4-digit passcodes are possible? And shall we reveal the results? So now it looks like a few of you, 2% of you are saying just 4 passcodes. 40, 9,999. There's definitely some contention here, and 6% are unsure. Well, how do we wrap our minds around this? Well, let's just kind of do this real simply here. Let me switch back over to doing a bit of math. And if we have here 10 possibilities for each digit. If there's 4 digits, each digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 possibilities. So if you think about the number of permutations, that's 10 possibilities for the first digit, times 10 for the next, times 10 for the next, times 10 for the next. And so if we do that out, 10 times 10 times 10 times 10, or 10 to the 4th, there are indeed, as 66% of you found, 10,000 possibilities. And so now we can kind of work backwards and decide how long is it going to take for an adversary to hack into this phone, because if it's one attack, one guess per second, well, that's going to map out to 10,000 seconds. But maybe not if the adversary isn't a roboticist or a human. What if they're like a software programmer, someone who's taken even a class introductory like CS50 and learned a little bit of programming? Well, a little bit frighteningly, it's not all that hard to hack into systems if you just know how to code too and really have the computer do your work for you. So in fact, let me go ahead and change over to another screen on my computer here. This is different for students in the group from VS Code. This is just a black and white version of it that we've used briefly in the past. And I'm just going to go ahead and create a program called crack.py. To crack something just technically means to figure out what it is, figure out a password in this case. And .py means I'm going to use a programming language that we here in CS50 have been dabbling in the past couple of weeks, with more to come next week as well. So it turns out, and you need not understand each of these lines of code, if I want to try maybe generating all 10,000 possible codes, I'm not going to bother with a robot. I've got all these cables coming out of my computer, and odds are one of them is a USB cable or a lightning cable. Surely we could figure out how to connect like laptop or desktop to phone and just like automate the process nowadays by just sending all of the numbers into the phone until one unlocks the trick, just like in the movies or TV. Well, in Python, I could write a program that does this as follows. I can import, so to speak, all of the decimal digits, 0 through 9. And this, for students in the room, is just a slightly better version of typing out 10 different numbers manually. I can also import from a library, so to speak, called itertools, for iteration tools, which means to do something again and again. I can import a function called product, which means the cross product, like combine this with this some number of times. And then it's just 2 more lines of code. I can use what's called a loop in programming. So for every passcode in the cross product of all 10 of those digits repeated a total of 4 times, let me go ahead and, rather than bother connecting my phone and hacking my own phone, let me just print out every one of those 10,000 codes on the screen, and we'll see how fast the hacker could do this. Let me go ahead and print, and with an asterisk, which is a little trick to format it nicely, I'm going to print out each of those passcodes. And that's it. 4 lines of code, maybe 40 seconds of talking, but maybe really 4 seconds of coding if I actually did this without the audience. And now let me go ahead and save the file. And I'm going to run, as we do every day in class of late, Python of crack.py. And when I hit enter, I should see on the screen all 10,000 possibilities from 0000 to 9999. So let's see. Is it a few seconds, minutes, hours, or days? Done. So barely even seconds plural, if that. So that should be a little disconcerting, because all that adversary needs to do is grab your phone off the counter, plug in a cable, and boom, they're done. Like there's no ticking clock or worries, as in the movies or TV, that maybe you're going to come into the room. You don't need that much of a window of time. So what would be better than this? Well, let's consider what our options might be if we don't want to just use 4-digit passcodes. Some of you indeed might have better passcodes than that, and maybe you use 4-letter passcodes instead. So A through Z, maybe uppercase and lowercase. That starts to make things a little more interesting. So should we poll this question too? If we upgrade from 4 digits to just 4 letters, English letters, A through Z, uppercase and lowercase, why don't we go ahead and poll the group here and ask how many 4-letter passcodes are there instead? So this time the range starts at 4. Still not the right answer, though, this time. How many 4-letter passcodes are possible? Not just yet. Just take a couple more seconds. All right. Almost a couple hundred responses in already. Few more seconds. And why don't we go ahead and reveal now the answers, which are, OK, so we've solved a couple problems at least. So OK, someone's just messing with us now. All right, so it looks like most of you, 76% of you, have claimed it's 7 million plus possibilities. So that's encouraging, because that's a whole order of magnitude more than before. Well, let's figure out how we might do this mathematically. So if we've got 26 lowercase, 26 uppercase, that's 52 possibilities now for each of those 4 digits. So that's 52 times itself 4 times, which indeed, either off the top of your head, a good guess, a calculator on the same device you're using right now, indeed gives us 7 million instead. Well, what might be slightly better than that? Well, maybe 4 characters. And this indeed is what your Macs, PCs, and phones are urging us to do nowadays. Not just numbers, not just letters, but like really annoying punctuation. So it really looks cryptic, not just to the adversary, but also to you and me, unfortunately. And that's the downside. But here now we have a mental model and really a computational framework via which we can evaluate the security of these. And I'll go ahead and spoil some of the math here. If we've got 52 letters of the alphabet, uppercase and lowercase, 10 digits, and if I count them out on my keyboard, about 32 punctuation symbols in typical English grammar, that actually gives us 94 possibilities now, which is up from 52, which is up from 10. So now we're really moving, and now that would give us 78 million possibilities. So another order of magnitude. Now, it's still going to be relatively fast, because you know what? I can actually do this. Let me go back into my code here. Let me reopen the same program, and I can point out just how easy it is to make these changes. Instead of importing digits as before, I can import, as your child might know, ASCII letters, which are A through Z, uppercase, lowercase. And I can just change this here, ASCII letters. And so this was that first version where we just changed to letters. Let me now rerun the code. And instead of seeing numbers, we'll see letters flying across the screen. And if I walk over here to the screen, we'll see that by the time I get here, we're halfway through the entire alphabet lowercase. If I now start walking away, I think, yep, we're already done now with uppercase as well. If I upgrade this slightly further, let's go ahead and take it one more level and perhaps do, let's say, ASCII letters and digits and punctuation. And this would be the Pythonic way to say that. And I'm going to add to those letters those same digits, those same punctuation symbols. Let me shrink my font just so the code still fits on the screen. And what we now have is, with 2 seconds of changes, a program that if I run this version, whoops, without the typographical error, this is what we call in CS50 a bug. So now we run the same. This is what we call in CS50 a second bug. Punctuation. OK. This is where I cross my fingers. OK, so now it's going to be a little hard to see as it flies across the screen, but you probably are seeing glimpses of some weird punctuation characters as well. And I won't waste our time trying to talk through this, because this is going to take longer. We're still in the lowercase. I'm still over here already. We've not even gotten to N, now O, then P. So this is going to run longer. But let's end with one final question on the security of all these systems. I'm going to cancel that by hitting Control-C on my keyboard. And let's ask the question instead if we use 8-character passwords. So twice as many characters. But even that is not terribly long, right? This is 8 characters alone on the stage. 8 characters using letters, numbers, and punctuation might be better. Let's do one final vote here, if we could. On your same device, how many 8-character possibilities are there now for these passcodes? And now 4 didn't even make the list this time. All right, a few more seconds, about 100 responses so far. How about we go ahead and, Carter, if you wouldn't mind, let's reveal the results based on the vote. A pretty decent spread here, although the quadrillions are quickly buzzing in and they're contending with the others here. Looks like 44% of you said quintillion, 34% said quadrillion, and this time, for the first time, you overbid. So indeed, if we go back to the math here, at least the majority overbid. If we have 8-character passcodes, that gives us 94 times itself 8 times, or 94 to the 8th power. And in fact, that gives us roughly 6,695,385,410,816 possible passcodes. Now, what does that mean? Well, the adversary's algorithm, the step-by-step code that they write to try to hack into your phone is no different. And honestly, if your passcode is 8 characters long, but they're 000000000, you're no more secure fundamentally. You really want to be somewhere in the sweet spot of that massive range of values, so that if the adversary tries this brute force attack just running through all possibilities, they will eventually reach your passcode. Just mathematically, it will be there. Hopefully, though, well, maybe not hopefully, you and I and they will be gone from this world, because that much time will have passed. And if we do out the math here, this number of seconds, for instance, is long past when we will no longer be here. So that's the sort of measure, is we don't sort of fundamentally change the equation for the adversary. It's still the same risk. It's still the same attack. But you significantly drive down the probability of success on their part, or conceptually, you drive up the cost to the adversary. And indeed, even in the physical world, this is true. You just want your passcode in the digital world really to be better than someone else's, because you want someone else's passcode to be the one that the adversary does something with. Just like in the physical world, even though it's a bit uncomfortable to consider, your house doesn't need to be 100% secure. And indeed, it's difficult to make it such. There's always going to be a point of weakness. Maybe it's that window, the door, or something like that. But if your home is more secure than the next door home, just probabilistically, you are more secure. You're not secure. And indeed, any website you see down the road that says, we are secure because we do X, Y, or Z, like, that's nonsense. Security is really about comparisons and evaluating things, if quantitatively, relative to some other system, relative to some other code. So what's the takeaway here? Well, hopefully a non-trivial number of you will go home this weekend on Monday and change at least one passcode. But there's going to be a trade-off here. We talk about this all the time in CS50. Anytime we improve something, we pay some price in time, in performance, in cost, somewhere else. So what's the downside then of this advice, that you should use minimally 8-character passcodes? Why might you want to say nay and not do this? Say again? You have to remember it, right? And so here there's sort of some sociology, there's some human behavior. You know, some of you might have colleagues if you're working in the real world, at least back in healthier times when you had colleagues with desks and cubicles, and there's probably one person in the office with like a Post-it note on their monitor with their passcode. You know, it's a bit of a cybersecurity offense, but it's also a sort of real world side effect maybe of corporate policies that aren't really calibrated for human behavior. So we'll see if there's some other defenses. And indeed, let me propose that we talk briefly about one that actually tends to kick in automatically. Even if your passcode is not as strong as we've just seen, one of these 6 quadrillion possibilities, well, what could we do instead? Well, has anyone, and I'll zoom in on this here, accidentally locked themselves out of their own phone before? Like, when does that happen? Yeah, when you try the password Yeah, so too many times. Maybe your finger's slightly off, maybe you're slightly off, and you just don't input the same passcode correctly after like 5 times, 10 times. There's some reasonable threshold. And why does that happen? Well, Apple and Google equivalently figure, just probabilistically, if after 10 guesses you still haven't typed in the right passcode, probably you're not you. You're someone else who's picked up your phone, so we're just going to go ahead and lock you out. Now, what's the effect of this? Well, this means now that each of those possible passcodes no longer takes roughly 1 second. Now it takes roughly 1 minute. So the attack is still the same, but if it's now 1 passcode or 10 guesses per minute, we have significantly, by a factor of 60 in this story, slowed things down. And unfortunately, does anyone know what happens if you screw up again after a minute? Yeah, it goes longer. It's like 5 minutes and then 10 minutes. And Google is kind of obnoxious about it. They don't even give you a time frame. They just say, try again later. And so that keeps not only the adversary out, but also potentially you. So therein lies that trade-off. If you've forgotten your code, if nowadays your finger is slightly wet so the screen isn't responding correctly, these could be usability downsides too. So security is really just about finding the sweet spot among these various trade-offs here. But there's other mechanisms too, and some of you might recognize this screen from Gmail, via which, of course, you log in. But after you log into Gmail or similar websites or apps or systems at work nowadays especially, you might be presented with what's called two-factor authentication. And what is this in a nutshell, in layperson's terms? Many of you, if you do anything digitally at work, might have to do this now. Yeah? Exactly. You get texted at your phone an additional code that's not your same password. It's typically a numeric code, maybe 6 digits long. It expires after a minute or 10 minutes. But why is this a good thing? Well, one, it's no longer just a piece of information that you know or that you might have written down. It's information that changes every time you try to log in. But more importantly, it's a fundamentally second factor, which means it's not just something you know. Now it's something you have. So you, for instance, are the only one, theoretically, that should be receiving that code. And so now the adversary, if they want to get into your account, not only have to guess or brute force or maybe read off of a Post-it note your password, they also have to physically have access now to that phone. So there's still a threat, absolutely, but it's not everyone on the internet with an internet connection. Now it's only the people in Starbucks. Now it's only the people at work. Now it's only the people in your home who might have access to that second factor. So there, too, it just raises the bar to the adversary, making it harder, more time-consuming, more geographically impossible for them to attack you. But what's the downside of two-factor authentication? Whether it's a device or even nowadays it's in software, whether it's on your keychain or on your phone, where you're prompted for this code, what's a downside? As some of us have probably experienced too. You forget your cell phone. Absolutely, right? The factor that you have, you don't have with you, or maybe you're in a basement somewhere, don't have reception, you're on a plane, you can't get the code. And so there, too, are these trade-offs. And even IT departments need to keep that in mind, because what does that mean for them? Well, if you don't have your phone with you and you are in the habit of calling IT to help you fix this now, there's a cost, a human cost, maybe even a financial cost. And so IT policy nowadays is really just about finding the right balance and where we want to spend our resources, but at least raise the bar to the adversary. But of course, there's other ways too. And this is going to be one of our homework assignments, if you will, after today. There's this software called password managers. And no need to buzz in on your phone, but maybe with a physical hand. How many folks here use a password manager? OK, let me ballpark this at 10, 20% perhaps. OK, so we've got 80% upside here and a lesson learned potentially. So a password manager is just a piece of software on your Mac, your PC, or your phone nowadays that manages your passwords. Well, what does that mean? When you go to a website for the first time or you download an app for the first time and you have to create an account, you can still use your email address or David as your username or whatever your name might be. So you don't have to change that methodology. But instead of typing in 1, 2, 3, 4, 5, 6 as your same password for that website or app as well as for every other, now you use the password manager software to generate something difficult to guess for you. That is, you tell the password manager, give me an 8-character random passcode, not 0000, but something with punctuation, with numbers, with letters. And better yet, the password manager, as the name suggests, remembers that password for you. And the next time you go to another website, you do it again with a completely different password, maybe same username, maybe two-factor authentication, but different password, different password, different password. And it doesn't have to be 8. I mean, I'm in the habit of using a dozen, 24 characters in total. And at that point, I can't even pronounce the number of possibilities because it goes well beyond the quadrillions. So the probability that someone's going to get into one of those accounts for me now is very, very, very low. And they're going to take less interest in me and maybe more interest in someone else that's not using as good of a password. Now, what does this mean in real terms? Well, when you go to log into that managed site, you don't manually type your password anymore. In fact, you don't generally even need to know it. Nowadays, I probably don't know 99% of my passwords. I entrust them to this password manager. Now, of course, you'd like to think that the password manager itself is secure. So what might that mean? Well, those of you who do use a password manager, how do you access that software itself? What's protecting your data in your understanding? So maybe biometrics, like your Face ID, or maybe your fingerprint, or maybe more simply, what else? Maybe just a password. And hopefully that password, that primary password, that gatekeeper is not itself 1, 2, 3, 4, 5, 6. Otherwise, it doesn't matter how secure all of the others are. But if you're willing to put in the effort and pick one pretty long, somewhat random, very unguessable password that you just promise to commit to memory, and maybe for backup, you literally print it out and put it in a safe deposit box or a safe, or just kind of hide it somewhere physically that there's very low probability someone's going to find the backup copy, that might be alone. But of course, the flip side is now, if you forget that primary password, you've now lost all of the eggs in the basket. If someone gets that primary password, now they have access to everything. So that's rather the trade-off. But I dare say you're probably less threatened, depending on your family, by the people immediately around you than the billions of other people on the internet that have access potentially to those same systems. So there too, it's a trade-off, and it's up to you to decide whether or not to manage your passwords in this way. But if you were on that top 10 list, or even if you're not, but you can think of several accounts that all have the same password, you're probably going to benefit from something like this. And why is it bad, to be clear, to use the same password on multiple sites? In case that's never sort of dawned in thought. Why is that a bad thing, to reuse a password on different websites, different apps? Any intuition? Yeah, and back? Exactly. Once it's attacked, you can the adversary, presumably by transitivity, can see, oh, well, if this user's username is mailin@harvard.edu on this website, and their password is foolishly 1, 2, 3, 4, 5, 6, or even something way more complicated, they can probably just assume with high probability that if I'm being a little reckless, let's try accessing mailin@harvard.edu's other accounts, other apps, using that exact same password. And so by transitivity, essentially, you're putting your other accounts at risk. So what's maybe a takeaway? Minimally here, I would start to reconsider your passcodes on your most important data. Maybe it's medical, maybe it's financial, maybe it's email, anything remotely personal that you really wouldn't want to have accessed. Do you necessarily need the same level of security on e-commerce sites or sites that you don't really care about, or that you signed up for once and after that, that's it? Probably not. So you can decide for yourself. But again, software like a password manager, and these are just some of the possibilities out there, are probably to be your friend. A couple of these are free. They come with Windows or Mac OS. A couple are commercial. Harvard has a site license for students for one of these as well. So there are options out there. But what else do people use? What else can people use to keep their system secure? So most of us nowadays have probably heard of encryption, this technique for just kind of scrambling information. So when you want to send a message, an email, or upload a photograph, or use your credit card, hopefully it's not just being sent out for all to see, but there's some kind of scrambling going on. And some fancy mathematics ensure that encryption ensures that only you, the sender, and someone else, the receiver, can theoretically see what that credit card number is, what that message is, what that photograph is instead. So encryption is sort of commonplace nowadays, both in websites and apps and ATMs and other such devices. But how does it work? Well, back in week 2 of CS50, your child learned a little something about encryption, otherwise known as cryptography. And one of the algorithms we talked about was quite simply something like this. This is what we might call not only CS50, but plain text. So very plain text that in this case is English, and obviously everyone in the room can read it. But what if I wanted to send this message out to someone in this room or out on the internet, or maybe equivalently back in the day, maybe write a message down on a scrap of paper in grade school and pass a secret note, a secret love note to someone in class with hopes that the teacher or any other students in the class can't intercept it and read it? Well, you probably don't want to say this is CS50 or I love you or anything remotely sensitive, but rather maybe you want to encrypt it. And let's change the T to a U. Maybe change the H to an I, the I to a J, the S to a T, the I to a J, the S to a T again, the C to a D, the S to a T, and we'll just leave the numbers alone, even though I worry someone could probably guess what this now does say nonetheless. But what was the algorithm as I rattled those changes off, whether student from week 2 or parent from week now? Yeah. Just a one-letter shift. And this is more sophisticatedly called a rotational cipher or a Caesar cipher after Caesar back in the day. It's relatively simplistic. But back in the day, it's not so simplistic if you're the first person in the world to ever use it or think of it. But nowadays, this is not actually what we use. But it's similarly mathematical in nature. It's not quite as simple as just adding 1 or subtracting 1 to go from now what we'd call ciphertext to plain text. But it's similarly math that's involved. And let me just stipulate that the way the math works is that the sender and the receiver just have to have in mind some kind of secret. And the secret in this case would very trivially be 1, but it could be a much bigger, much more unguessable number, or maybe some other secret we share. The presumption being that my classmates, my teacher in that grade school classroom, if they don't know what that secret is, that number is, yeah, they could try to brute force it and try all possible mathematics, +1, +2, +3, but that's going to take them some time, and they probably don't care enough, and so my data might be, and therefore, relatively secure. But we use encryption all the time nowadays, and so for instance, this is at the start of most URLs nowadays, even if you don't type it yourself. With that said, Safari and even Chrome now are kind of simplifying, if not dumbing down, user interfaces to just hide details that you and I, as sort of normal users, don't need to see 24/7, but it is there. And if, in fact, on your phone or laptop, you click on the URL, even if it's super short initially, you'll probably see the whole thing starting with this. And the S means secure. The S means that encryption's being used. But there's other forms of this, not just when you visit websites. There's this, end-to-end encryption, which is being talked about more nowadays, especially during COVID times with so many more of us on video and talking about more sensitive things, telemedicine, talking to doctors, things that you also wouldn't want to verbally or visually get out into the wild, just like text. What's different about end-to-end encryption versus HTTPS and the type of encryption that most of us use every day on websites alone? End-to-end encryption is sort of a better feature that you want to increasingly seek when using services like Zoom or Microsoft Teams or WhatsApp or the like. Any instincts here? Yeah, over on the right. Good. So the encryption, the scrambling of information happens in the source, the sender, and the destination, the receiver, without a so-called middleman in between. And this is actually very different from most contexts nowadays that use just HTTPS, because when you're using HTTPS to buy something on Amazon securely with your credit card, well, of course, Amazon needs to be able to decrypt the message at the end of the day, and so that's fine. But even when you're using services like video conferencing or maybe text messaging nowadays, well, if you're using WhatsApp, that's owned by Meta. And if you're using Instagram, that's owned by Meta. I mean, there's a lot of middlemen in these apps that we're using. And if they were only using encryption, period, or only using something like HTTPS, yes, your connection from you to WhatsApp and in turn to the recipient might very well be secure on each end of that channel. But Meta, in the between the company and any other company in between, could theoretically, for better or for worse, be looking at that data, whether it's to mine it for advertising purposes, whether it's to snoop on data that you're sending. That is not end-to-end encryption if the middleman, a company typically, has technically access to that data. Now, Zoom and Microsoft Teams and WhatsApp and iMessage and other services with which you're familiar increasingly are offering stronger guarantees of encryption, whereby it's indeed between parties A and B and not the one in the middle. Now, there's downsides here, and you can actually see this kind of functionality manifest in certain settings. For instance, besides iMessage which just does this for you on iPhones or Macs. Besides Zoom, you can actually fine-tune these settings, indeed, within Zoom itself. So here's a screenshot that I took last night of just what the user interface looks like today to create a new Zoom meeting with the latest version of Zoom software. And maybe unbeknownst to you, there's a choice of buttons down here. And most likely, yours is by default on enhanced encryption, which is brilliant marketing speak, because it's just encryption. It's not enhanced. It actually, ironically, means worse than this. But they want you using it most likely. Why? Well, it's a little easier to implement. It's a little less expensive for them computationally. And to be fair, enhanced encryption does scramble the data, but not in a way that Zoom can't see it. Zoom can indeed see it, but that's actually a plus in some context, because if you want to do like cloud recordings and you want a meeting recorded not on your Mac or PC, but like let Zoom deal with that. If you want automatic transcription nowadays, so the words to appear, whether it's English or something else on the screen, well, you can't really lock Zoom or any other middleman out of that, because someone needs to save it to the cloud. Someone needs to translate the voice to those English or some other language words. So enhanced encryption enables those features, but they also allow a bad actor, malicious employee, someone who's just nosy at Zoom or the equivalent middleman to just kind of poke around your video conference and hear what you've said or see what you've typed as well, unless you instead check this box as well. So increasingly look for mentions of end-to-end encryption, or give that some thought when you choose a technology via which to communicate with someone, whether it's within your family or without as well. Now, last but not least, there's other applications of encryption too, and this too might be a lesson learned as well. Full disk encryption. So a disk is like where your data is stored in your Mac or PC or even your phone. And full disk encryption just means ideally that all of your data is encrypted, that is somehow scrambled. Now, hopefully your password for your computer or phone is good enough that even though the device is encrypted with that password, at least you'll remember it, and your phone or your Mac or PC will automatically decrypt it for you. Of course, you can't scramble the information and hide it from ourselves. One of us, at least for these devices, needs to have access. But full disk encryption typically means that at least when you close the laptop lid or power down for the night, that even if someone else steals that device, opens the lid, unless they have your passcode, they can't even plug in fancy cables to the device and just rip the zeros and ones off of the device and see what's actually there. Full disk encryption means they could do that, but they would just see seemingly random zeros and ones. Now, there's a downside here too. This might slow things down potentially, but it is a feature increasingly that's offered and is absolutely something you should consider enabling in general, especially if your laptop or phone travels with you, and certainly your phone does, or if you plan to donate or sell or give away a device. You don't want to leave all of the zeros and ones, the remnants of your own sensitive data passed on there. So Windows has a feature called BitLocker. Mac OS has a feature called File Vault. There's commercial options as well. But generally, we're at the point now in 2022 where clicking a button is sufficient to enable these features. With that said, don't rush into all of these decisions. I would make backups of your data, and don't maybe email CS50 if something goes wrong with that process. But I would do your own due diligence, but this too would be a menu of possibilities. And now the bad side, the downside of what seems to be great, this notion of full disk encryption. Unfortunately, just as we can encrypt our data to protect it from the adversaries, so can the adversaries, if they get into our devices, encrypt our data and do what? Not tell us that secret key. And so this is generally applied in the context of ransomware, which tragically you increasingly hear about in hospital systems, school systems, municipalities, where systems are getting attacked and the data is not just getting stolen, because what does the adversary typically need with like local municipal or even hospital data? The value to the adversary is encrypting all of the hospital, all of the municipality's data, preventing them from accessing it if they have no backups or the like. And so ransomware is literally about trying to convince someone to pay you money or pay you Bitcoin or something like that to give you that secret key. And this key in this case is surely more sophisticated than the number one, but it's really the same idea. So here too, yet again, a trade-off. Just as we sort of invent something for good, it can also be used for evil, in so to speak, as well. But it's really the same underlying principles, even though we keep seeing it and hearing about it in these different forms. And lastly, if only because folks are generally familiar but don't necessarily know what it is that it's doing for them, browsers nowadays have what's often called incognito mode or private mode, which has nothing to do with encryption but does have to do with cybersecurity, or really cyber privacy, keeping your data from prying eyes. Incognito mode, if you open it in Chrome, for instance, looks a little something like this. And we use it in CS50 when introducing students, as we did last week, to web programming, because it, in effect, lets you start with a clean slate, like a brand new browser that has never visited any websites before, which is good for just diagnosing problems. But it's often commonly used if you want to log into maybe your Gmail account on someone else's computer and you don't want your password being saved, or you want to visit some website where you don't want the URL or the search terms ending up in your autocomplete history. So there's multiple uses for incognito mode. But what does it really do? Well, it doesn't stop your company. It doesn't stop your university, your internet service provider, be it Comcast, Verizon, or the like, from knowing what websites you go to. Because ask your students. A week ago, we talked about how the internet works. And unfortunately, every computer has an IP address, which is a unique identifier, which goes out anytime you go anywhere, incognito mode or not. So this isn't really covering your tracks outside of your office or outside of your home or outside of your company, but it is at least throwing away local information. And so we'll talk, in fact, in CS50's week 9 this coming Monday about cookies, which you might generally know about, and what are called sessions. And so long story short, what incognito mode does is it throws away, when you close the window, any locally stored information, these things called cookies, which are sort of like virtual hand stamps that just remember what you've logged in as or what's in your shopping cart or the like. But it doesn't hide any information from anyone outside of your own Mac or PC. It only prevents those local prying eyes. So there too, even though we have tools that many of you are probably in the habit of using or thinking you should use to be more private, be more secure on the internet, what we do really in CS50 both weeks past and future is talk about how these technologies work so that ultimately we have all the more of an educated citizenry here among undergrads and here as well as online, so that you can apply these same lessons learned to problems you'll encounter in the future. So as promised, the homework. 1, should probably use a password manager. It doesn't have to be one of those ones on the list, but at least starting that conversation maybe with someone who does, maybe it's often the student in your family perhaps who can advise you on some of these technologies. Consider using a password manager. 2, using two-factor authentication, whether it's your phone or some key fob or the like, but at least seeking out that feature, at least for accounts that you really care about. Your email, social media, financial, medical, anything where you'd be embarrassed at best or really violated at worst if that kind of information got out. And then increasingly using not just encryption, which you kind of get automatically from most technologies today, but increasingly choosing technologies that offer stronger guarantees that keep those middlemen, those companies out of the way, if only so that you can trust with higher probability that only party B knows what party A has said or sent. Now, this, of course, was a whirlwind tour. There's so much more that you can do online. Indeed, this course, CS50, can be taken for free online via platforms like edX at edx.org/CS50. I thought it might be appropriate to end on this note. If anyone would like to conjecture, before we start playing music and adjourn for lunch, what our final message here is, if we reverse the +1 and maybe start -1 here, -1 here. And indeed, thank you so much for coming. This was CS50.